Welcome to this course, Blazor Deep Dive, Beginner to Advanced in .NET 8. In this course, we're going to build a few projects while we dive deep into the world of Blazor. The main project that we're building is a server management project, where we are managing servers in different cities. And we are able to search servers by using the search bar, and we are able to turn on, turn off the servers, and edit the servers as well. We are also able to delete the server. As you can see, we also cover authentication and authorization, some of the user management. Another project that we're building is this to-do list. So you can manage to-do list by using Blazor, and you can mark them as completed. Finally, with Blazor WebAssembly, we're building the server management again, but this time it's a simple CRUD operations with add server from the add server screen, added server from the added server screen, and delete server. These are all the sections in this course. You can see that we cover every aspect of Blazor and we really dig deep into them. On top of that, we also cover data access for static server-side rendering or server interactivity with Entity Framework Core. And we cover data access for WebAssembly interactivity by invoking web APIs. We have also authentication and authorization, which is for securing our Blazor application. Throughout this course, you're going to work on a lot of assignments in order to practice what you learned. Now let's go into each section. In the first section, we're going to talk about what is Blazor and different choices of interactivities, and also basic Blazor project structure. In the second section, we're going to dive into Blazor static server-side rendering. This is the base of everything else. So we're going to talk about the basic stuff like reader syntax, basic component concepts, component parameters, form submissions, validations, and so on and so forth. In each section, we will have more advanced lessons like this. In the next section, we're going to add interactivities based on SSR. We'll start with what is interactivity, and we're going to talk about things like interactive locations, event handling, update state variables, two-way data binding, and interactive edit form. Again, we have advanced lessons for this section as well. In the next section, we are going to work on a course project based on what we already learned. So you have more time to practice what you learned. Now the next one is all about non-routable component. Blazor is component-based application framework. Therefore, thinking in components and being able to work with components is very important in Blazor. And this section is all about components, how to extract different components from existing page component, event callbacks, how to reference child component, so on and so forth. And then again, we have more advanced topics. And then we're going to work on the course project again by componentize everything. Now we have more advanced topic like lifecycle deep dive. It is essential for working well with Blazor. Therefore, this section is very important. Next one is routing and navigation deep dive. So we have more advanced topics about routable component. State management is also another advanced topic. It's something that you also need to understand when you really work on real-world projects. After that, we're going to talk about WebAssembly. Most concepts that we have learned in server interactivities work in WebAssembly interactivities. So in this section, we're going to talk about the different parts in WebAssembly comparing with server interactivity. The next two sections is all about data access. First of all, we're going to talk about data access for SSR or server interactivity, where we're going to use Entity Framework Core. And after that, we're going to talk about data access for WebAssembly, where we're going to consume web APIs. After that, we're going to come to this important section, which is securing our application with authentication and authorization in ASP.NET Identity. And last but not least, we are talking about pre-rendering in Blazor, which is a topic that we have to understand. As you can see, this course is a deep dive into the world of Blazor, where you will learn to harness the power of both server-side rendering and WebAssembly rendering to create dynamic user experiences. I really hope to see you in the course. In this video, let's talk about what is Blazor. In one sentence, Blazor is a component-based single-page application framework that achieves interactivity with C#. So you can see that there are two parts in this sentence. The first part is that Blazor is a component-based single-page application framework. And the second part is that it achieves interactivity with C#. So let's talk about the first part, which is the component-based single-page application framework. And that is different from the traditional web application frameworks. For example, under the Microsoft ASP.NET Core paradigm, we have MVC or Razor Pages. A traditional web application framework works like this. You have a user who uses a browser to access the web application. The user sends requests through the browser to the web server at the backend. So this is a request. The web server is responsible to route the request to its corresponding page. And then the HTML that is defined in the page will come back to the browser and will be rendered inside the browser. And if the user sends a different request through the browser to the web server, then the web server is again going to route that to a page. That could be a different page, it could be the same page. Let's say this time the second request comes and it is requesting information from the second page. Then the web server will route the request to the second page, and then the HTML defined in the second page will come back through the web server as a part of HTTP response and come back to the browser, and then eventually the user sees the HTML for the second page. So as you can see that this type of framework is based on pages. Each request target a corresponding page. Well, that is different from component-based single-page application framework. In the component-based single application framework, of course, we're going to have a user, we're going to have a browser, and of course, the user is going to send requests to the web server as well. So those are not different at all. However, the web server is going to route the request to one page and only one page. And so this is, you can call it the root page, or more properly, it's called the root component. Because it's component-based application framework, everything is component. But you can still call this root component a page if it's easier for you to understand. So all of the requests, no matter how many requests the user sends, it will always go to one single page. And then the Blazor framework is going to look for different components. And what it's going to do is going to find a component and place that component inside this root page component. For example, this first request comes, it knows that it needs the component 1, then it's going to place this component 1 inside the root component. And then maybe the next request comes, it needs component number 2, then this time it's going to replace component 1 with component 2. From the outside, the user sees the same as a traditional web application framework. Right? It just changes page by page. But at the backend over here, you can see that this is no longer page-based application framework anymore. This is component-based application framework. And on top of that, each one of these components may consist one or more child component. So for example, this component may have 2 columns, and each column is implemented by using a component. And furthermore, this left component may have its own child components. So therefore, we have a component tree, and there could be as many levels as necessary. When you start working with Blazor, if you had experience with traditional web application frameworks, you will immediately see the differences between traditional web application frameworks where you are working on different pages. Here in Blazor, you are working on different components, and you will be thinking in components instead of pages. And so that's the first part of the statement. In the next video, we are going to talk about achieving interactivity with C#, which makes Blazor completely different from other single-page application frameworks like Angular, React, Vue.js, because those single-page application frameworks uses JavaScript to achieve interactivity, whereas in Blazor, we're using C#, but we're going to talk more about it in the next video. In this video, you just need to remember that Blazor is a component-based single-page application framework where you are going to think in components instead of in pages. All right, that's everything I want to talk about in this video. I will see you in the next one. In the previous video, we talked about the first part of the statement, which is Blazor is a component-based single-page application framework. In this video, we are going to talk about the second part, which is it achieves interactivity with C#. So then what is interactivity? Let's take an example. If we have a page, and on this page, we have a list like this. Now, we want to allow users to search lists based on a filter and only produce the list that matches the filter. For that, we may have a search bar like this. So you're going to input something here, and then you click on this button, and you expect this list to change. In a traditional web application framework, or in modern single-page application framework like Angular, React, Vue.js, you have to implement this with JavaScript. So we click on this button, you code some JavaScript. You use JavaScript to call the backend data. Once you retrieve the data, then you will render this list with JavaScript again. So that's how you do it in other single-page application framework. Whereas in Blazor, we are going to use C#. So therefore, you can see that we're going to use C# on the front end as well as on the back end. So that's one of the best parts of using Blazor. You no longer have to rely on JavaScript, although in some cases you still need JavaScript, but not as much as before. You're going to find yourself use C# in more than 90% or maybe 95% of the cases. In terms of interactivity, Blazor implements interactivity with different options. And the first option is, ironically, no interactivity. So Blazor provides you a way to implement your application without any interactivity if your application does not actually require interactivity like this. That's actually the base of all of the other interactivities. In the next video, we're going to talk about the project structure, and you're going to see exactly what I mean here. So this is the base. And this is also called Blazor Static Server-Side Rendering, right? Blazor SSR. So in most cases, you are going to create a Blazor project as Blazor SSR. That means without interactivity. And you will only need to add interactivity to this when you need interactivity. For example, in this case, we need interactivity here. And when you need to add interactivity to Blazor SSR, there are two different ways to add to it. The first way is called Server Interactivity, and the second way is called WebAssembly Interactivity. We're going to borrow this diagram here. We're going to start with Blazor SSR, right, which is the same as traditional web application, where the user interacts with the browser, sends a request to the web application, and our Blazor web applications is going to render HTML back to the browser as HTTP response. Right, so this is Blazor's static server-side rendering, which is Blazor SSR. And if we find that we actually need interactivity in our components, maybe a different page component, then we have a choice to use server interactivity or WebAssembly interactivity, as I mentioned before. When we use server-side interactivity, how it works is that Blazor is going to help us to establish a SignalR channel, which is a WebSocket channel. I'm using this silver bar to represent the channel that is established between the browser and the server, which is a peer-to-peer communication, and that connection needs to be sustained in order for the communication to be working. And in order to help the browser to be able to talk to the backend applications through this WebSocket channel, there's a JavaScript file that is placed inside the page that is rendered in the browser. Right? This JavaScript file is not created by our developer. It's created by Microsoft. So we have this JavaScript file that helps us to communicate with the backend server. Whenever the user does something, enter something in an input box, or click on a checkbox, or click on a button, that events will be handled by this JavaScript and send that request to the backend server. And the request is processed by the backend server, and it's going to see the original HTML and the future HTML. It's going to compare them and only send the diff, right, the difference between those two, back to the browser. And then the JavaScript file here is going to be responsible to render that difference inside the browser. That way, Blazor is only re-render the page partially. It's not re-render the whole page. And that is different from a traditional web application where the whole page is refreshed every single time, right? So that's how server interactivity is achieved. And now let's talk about WebAssembly interactivity. Again, WebAssembly interactivity is based on Blazor SSR, right? This basic scenario. Now, the components that require WebAssembly interactivity will be packaged together with .NET Runtime and all of the dependency it allows and a WebAssembly file, right? They will be packaged together and sent over to the browser, because all of the modern browsers support executing WebAssembly. And actually, executing WebAssembly is even faster than executing JavaScript because it's near native speed. So therefore, when we have even the .NET Runtime downloaded to the browser, your C# code will run within the browser, supported by .NET Runtime within WebAssembly. Right? That's the default scenario. There's another scenario where your component that needs to support WebAssembly interactivity will be compiled into WebAssembly, and then it will be downloaded to the browser as WebAssembly, right? So there's no .NET Runtime needs to be packaged anymore. Anyway, whether you use the first approach or the second approach, some kind of files will be downloaded from the server to the browser and eventually executed inside the browser as WebAssembly. And therefore, you can see that we can use C# inside the browser through WebAssembly. And actually, there is a fourth scenario where you can mix and match between the server interactivity and WebAssembly interactivity, even on the same page. Right? When you look at the one screen on the browser, even on that, you can have one component that uses server interactivity, the other component uses WebAssembly interactivity. Right? Throughout this course, we're going to talk a lot about server interactivity because it's just very easy to teach. And most of the concepts will apply to WebAssembly as well. Now, later in this course, you will see sections about WebAssembly and what is the difference between server interactivity and WebAssembly interactivity. And you have chances to practice using WebAssembly interactivity as well. But for this video, you just need to remember that Blazor SSR, which is the base of everything. So you're going to create a project as a Blazor SSR normally. And then when interactivity is required, you have a choice to add either the server interactivity to the Blazor SSR or the WebAssembly interactivity to Blazor SSR. Or you can add them both and use them together. And throughout the course, you will learn how to do that. So this is everything I want to cover in this video. If you have any questions, please let me know. If not, I will see you in the next one. In this video, let's start creating our Blazor SSR project so that you can start understanding the project structure of Blazor SSR, which is the base of all of the other type of Blazor project. Okay, let's go to Visual Studio here. And what I have here is Visual Studio 2022 version 17.8.6. So let's go to File and go to Create a New Project. And here, what we're going to search for is Blazor Web App. So Blazor in the past have different variations. In .NET 8, it's combined into one template, which is Blazor Web App. You are going to see other older templates like Blazor WebAssembly Standalone, Blazor Server as well. Blazor Web App is the template for .NET 8, and it's the recommended template. So therefore, we're going to choose the Blazor Web App template. Let's click on Next, and then you choose a location, provide a solution name. Here, I'm going to call it Blazor Deep Dive. And this project is a server management project. So we're going to create a server management application for teaching purpose. Now click on the next button, and we have this complicated screen here. Of course, we're going to select .NET 8, and then we're going to leave the authentication type as none because later we're going to add authentication to it. For now, just leave it as none, and we're going to keep this checked because we're going to use HTTPS. And for now, we are going to keep this interactive runner mode as none. We open it up, you can see that we have none, server, WebAssembly, and then we have this auto. So none means there's no interactivity, which is the base of everything and which is the Blazor SSR, static server-side rendering. So we are going to select none. And then later we're going to talk about the option of server, option of WebAssembly, and the option of auto. But for now, if we choose none, that means we're working with Blazor server-side rendering. In fact, when you create a project, I suggest you to select none at the beginning because in your application, you're going to find a lot of pages are static pages and you don't need interactivity. Therefore, you're going to select none and then you are only going to add interactivity to the components that actually requires interactivity. Once you select none, this interactivity location doesn't actually matter, right? So just ignore it. And we're going to include some sample pages and then click on create. Let's close this and focus on the right-hand side here in the solution explorer here. And as you can see that if you have worked with C# project, you are going to be very familiar with this program.cs. This is like a console application. When this app.run is running, it basically runs in a loop and listens to HTTP request comes in. And then once the HTTP request comes in, it's going to go through these functions. And these functions is called middleware. So it's going to come over here and then go through here, go through here. Each one of them either add different things to the request or handles it with certain functionalities. When it comes to this map reader components here, this middleware is going to map the HTTP request to the app class. So what is this app class? Let's open up this components. This class, when you click into it, you can see that this is a plain HTML page, except that it has a root component and a head outlet component. So this app.reader component, because it has HTML, and you're going to find that this is the only place that has the HTML element here. So this is the root component. All of the requests that comes into this program is going to be mapped to this root component over here. And when we say Blazor is a single page application framework, the single page is referring to this root component, which is this app.reader component. And then this root component uses a roots component to find corresponding component. In previous lessons, we talked about how Blazor works. The web server maps to the page, which is the root component. And then Blazor finds the component and place that component inside the root component. Here, we're seeing this actual root component, which is this app.reader. And then the roots component here is taking the responsibility of finding the corresponding components, whether it's component 1, component 2, or whatever component you name it. And let's go to this roots component, which is actually sitting right here. And this is actually a router component. This router component finds the corresponding component, like I said, whether it's component 1 or component 2 or whatever the name that you give it, and applies a master layout, which generates a HTML, right? A final HTML result. And that final HTML result will replace the router component, which means that if we come back to the root component, the final HTML result will replace this. And therefore, we're generating a beautiful HTML result. And then another request comes in to this program.cs. It's going to again map to the app component. From the app component, it goes to the roots which is the router component. Okay, so let's go to the roots component here, and then the router component is going to find a corresponding component and then applies the main layout again, and then generate the HTML result. And then it's gonna replace this with the HTML result, and you have a complete HTML result rendered to the browser. So the only piece of puzzle here that I didn't explain is how this main layout works. Right? How is this main layout applied? So let's go to the main layout, which is actually under the layout folder. Here you can see that the main layout also has the same extension name, which is .razor. That means it's a razor component, which is actually a Blazor component. Blazor component is technically called razor component, right? That's why it has a .razor extension. And here you can see that it has some HTML, and then there is a add body. So this add body is a placeholder for any components. No matter which component is required by the user, it will come over here and replace this add body placeholder. So that's how this layout is applied to your custom build component. Once it replaces this body placeholder, this is the HTML result. And this HTML result will replace the router component here. And then in turn, it replaces the roots component here and generate the final HTML that can be displayed inside a browser. So this is how it all works in theory, the whole sequence. First, it comes to program.cs, then it goes to app.razor, which is the root component. Then it goes to the roots component to find the custom component. And then it applies the main layout, and then the final HTML is going to be rendered inside the browser. So 1, 2, 3, and 4. All right, so let's actually run this application and see it in action. The application is running. And first of all, let me show you that in addition to this browser that is launched, I have a console application that is launched as well. When I hover over here, you can see that this actually points to my solution debug folder, and you can see that it says server management.exe. So this is actually a console application, and it tells you that it's listening to localhost at 7152 port number, or it's listening to this at a different port number. And then it tells you where the root path is. So this is the root path. This shows you that this is actually working as a console application, and this console application is listening to 2 different ports. Right? When the request comes in, then the programs.cs right here will start picking up the request and process the request through different middleware. Okay, let's come back and focus on the application itself. What you're actually seeing mostly is the main layout. Okay, so let's take a look at the main layout again. So main layout.razor, and then it has a sidebar. You can see sidebar here on the left, and then the main area on the right. Pay attention to this body here. I'm going to come back over here. So this is the sidebar on the left, and then this is the main area here. So what is being displayed here is the home component. When I click on the weather link here, and as you can see that the left hand side didn't change, right? Because it comes from the main layout, only this part changed. That means the whole sequence that I mentioned is working, right? So because it goes to this URL, then this program.cs map that request to the root component. The root component then uses the roots, which is the router component, to find the corresponding component. And where is that corresponding component? That is under the pages folder here. So that's the weather component. And then the router component here is going to apply the main layout to the weather component, which means all of the HTML inside the weather.razor, right, inside this weather component, will replace this body placeholder, and then this final HTML will replace this component over here. If I open up the developer tool here on the right hand side like this, you can see have this framework blazor.web.js, which is inside this root component here. On the top, we don't see roots anymore. What we see is div, class, page, and where does this come from? Okay, pay attention to here. So that we have this script tag here, and then above that is a div. So where does this div come from? That is from the main layout. Here, you can see div, class, page, and then we have a sidebar here. Coming back over here, we have this div, class, page, and let's open it up. Then we have sidebar on the left, and then the main area on the right. Everything inside here is from the actual weather component element here. That's from the weather component. When we go back, you can see that the inner content of this article element is replaced. And where does this content come from? That's the home component over here. So it's under the pages folder, we have this home component. You can see that it's exactly the HTML inside the browser over here. Okay, so in this video, we have gone through this whole process for rendering this basic application. We have seen how the request is handled through different levels of components. And through this example, I hope you can see this project structure of Blazor very clearly. So this project structure is the project structure for Blazor static server-side rendering. It is exactly the same if you want to add server-side interactivity. But when you want to add WebAssembly interactivity to your application, there is going to be another additional project added, but how this part works stays the same. So that's why I say that Blazor's static server-side rendering is the base of everything else. Okay, that's everything I want to cover in this video. If you have any questions, please let me know. If not, I will see you in the next one. In this video, let's talk about the types of components. By now, you know that Blazor is a component-based application framework. Therefore, component is everything. And there are two types of component. The first type is called the routable component. Sometimes it's also called the page component because the routable component acts like a page. And of course, the second type is non-routable components, which is also sometimes called reusable component. Let's borrow this diagram that we used previously. So we have a user send a request through the browser to the web server. The web server is then using the map_router component middleware to map that request to the root component. Then the root component uses the router component to locate the actual custom component to be placed inside the root component. Depending on which component the user requires, it then places that component inside the root component. So all of these components that I specify here, component 1, component 2, or component 3, they are routable components because the router component is able to locate them by using the URL. And then on this picture, what are non-routable components? They are here. So non-routable components can be used inside each one of these routable components, or can be even used inside other non-routable components. So these are the two types of component. Now let's jump into Visual Studio and start creating these components so that we can actually understand them better. I'm in Visual Studio now, and now let's create a routable component. So we need a routable component to act like a page for us to manage our servers, because like I mentioned before, this application is a server management application. So we're going to create a page component. And whether it's a routable component or non-routable component, they're all Razor components. So technically, they're called Razor component, as I mentioned before. So I select Razor component in Visual Studio. And because it's a routable component, it acts like a page. I don't want to have this component as a suffix. I just want to remove it, and then I'm going to give it a name. I'm going to call it servers, because this page is going to show us all of the servers for us to manage. So we're going to click on add, and then this servers.razor component is created. Now, what makes a component a routable component? The single most important thing is the page directive at the top. So as you can see, all of these components are actually under the pages folder, which means they're all routable component, and if you click on home, for example, it has a page directive right here. Go to weather, it has the page directive right here. So for us, we are going to add the page directive as well. And this page directive is the single most important thing that marks this component as a routable component. And inside the double quotes, we're going to say slash and then followed by the relative path. So for us, I'm going to say servers is the relative path. Let's run the application. All right, our application is running. There are no links over here to link to our servers page. But what we can do is we can manually type in the URL. So we'll follow the relative path. I'm going to say slash servers. Hit enter, and we can see servers, which is the title. That's the only thing on this page so far. That means we're able to navigate to this servers routable component. So again, what happens is that the root component uses the router component over here to find or locate our servers component. And then it applies the main layout to it, and it replaces this part of the HTML with our own component. Right? Well, our own component only has this one line of HTML with all of the other HTML from the main layout. So this is the routable component. So you only need to remember one thing for routable component, that what makes a component a routable component is the add page directive. Now let's create a non-routable component or reusable component. And for that, I'm going to actually create a folder. I'm going to call it controls. I like to call reusable component or non-routable component controls, which corresponds to pages because there are controls in pages. Right? You can just call it components if you like, or anything you like. Okay, so under this controls folder, I'm going to add another razor component here. And this time, I want to keep this suffix here, and I'm going to call this server component. Click on add. This time, I don't need to add the add page component because we are not going to actually navigate to the server component. The server component does not act like a page. It acts like a partial view. So I'm going to delete this, and I'm going to just use a paragraph element here. And I'm going to say server is online, something like that. And let's just close it. Now, since we created the server component, we can actually use the component inside another component. So where do we want to use it? Of course, we want to use it inside the server's component. So let's add a line break here, maybe another line break here, and then we can directly use the server component as a HTML element, right? So we can have a less than sign here, and then I'm going to say server component, and then use a greater than sign. And this references to our server component. As you can see that it includes all of the namespace. And there are two ways to get rid of this. So the first way is just to delete it and then use a using directive right inside this server's routable component. So just do it right here. And now you can see the red squiggly line is gone. Right? We can do it this way, but I prefer the second way, which is place this using statement inside the imports component here. So we have this imports component, which is the global place or the central place where we can place our namespace. If I place this namespace inside the imports.razor component, that means all of the other components can reference the classes or the components under this namespace, right? Because I'm going to have many controls, so that's why I prefer to place this namespace inside the imports.razor component so that in the future when I create other components, I don't have to reference this namespace every single time, right? So let's just keep it centralized. Let me close this and come back to this. So I have one server component. I can actually render as many server components as I want. So let's say I'm going to have 2. And then let me go over here and restart the application. Now you can see that I have this server's routable components, and inside it, I placed two non-routable components. So in this video, you have learned how to create a routable component. It's also called a page component, and the most important part is to use the add page directive to specify a relative path. And then you also learned to create a non-routable component, which is also called reusable component. And then we are actually reusing the server component twice inside the server's component. That's everything I want to cover in this video. If you have any questions, please let me know. If not, I will see you in the next one. In this video, let's talk about razor syntax, specifically implicit razor expression. We have mentioned that Blazor achieves interactivity with C#. So interactivity is something at the front end, but at the back end, we also need to use C#. Right? That's one of the advantages of using Blazor. So at the back end, we need to use C#. And how do we write C# and then reflect that in our web page or components? That's when we need to use razor syntax. So let's jump into Visual Studio and see what I mean by using razor syntax to reflect C# variables inside web pages. So let's take a look at our server component that we created in one of the previous videos. So let's go in here, and as you can see, we only hard-coded server is online. So we cannot always hard-code something because obviously our application framework should allow us to work with dynamic stuff, right, which is variables. So let's say we declare a variable, and we're going to say status. Let's initialize it with server is offline just to make a difference. And how do we display this C# variable value inside HTML? That's when we need to use razor syntax. One of the simplest one to use is the implicit razor expression, which means that you start with the @ sign followed by a variable or a statement. For example, we can say status, and then when the application runs, it's going to actually take the value from the variable and then replace this razor expression. So you're going to see server is offline. Let's give it a try. Let's go to our server's page component over here, and we can see that server is offline. Right? So this is no longer hard-coded in the HTML part. It comes from our variable. Right? As I mentioned, implicit razor expression can be either a variable or a statement. So let's say I have a space here, and then I'm going to say at followed by another implicit razor expression that is going to show us the time. So I'm going to say date time, and then I'm going to say now. Now I have two implicit razor expression here. First one is using a variable, and the second one is kind of using a statement. And as you can see, a razor expression cannot have a space. So once you have a space, then the rest of the things are considered as HTML. So the at is considered as HTML. And then here, when I have another at sign, then everything else, as long as there's no space, this is considered as implicit razor expression. So let me give it a try. I'm going to go over here and click on Restart Application. And let's take a look at this and see we have server is offline at the time, and this one is the same. So this is the basics of implicit razor expression. Now let's create a server class to represent a server. So let's go to our server management project here and create a new folder, and let's call it models. So we're going to have the classes created under the models folder here. And I'm going to have the server class here. And we're going to add some simple property. For example, we can have server ID is online, which represents whether the server is online or offline, and then the name and which city the server is located. And for now, I want to randomly generate the status, which is whether it's online or offline. Okay. So I'm going to generate it from the constructor here. We're using our random class here to generate a number between 0 and 1. And then we use that number to generate a Boolean value, whether it's false or true. So now let's come back to our server component here. So here, instead of just use our status variable, let's remove this, and let's remove this as well. So here we are going to have our server class here, This requires our namespace, and as I mentioned before, I'm going to centralize that namespace inside the underscore imports component here. So I'm going to say server management dot models, so that later when I add more classes into the models namespace, I don't have to import namespace every single time. As you can see, that immediately that fixed our problem here. I'm going to just initialize it right here. And then over here, I'm going to give it a name, server1, and the city is Toronto. And here, I'm going to use Blazor expression here and say at server.name, and I'm going to use a space here. So is in, and then I'm use another implicit Blazor expression here. I'm going to say server.city. All right, so let's give it a try. Go over here and restart our application. And let's come over here. It says server 1 is in Toronto. This is all I want to show you in this video. You just need to remember that to use implicit Blazor expression, you just need to start with @sign. Just remember not to include a space. If you include a space, then the things that after the space is not considered as part of the Blazor expression anymore. It's considered as part of the HTML. And then you can add another Blazor expression afterwards. Another thing I want to make it clear is that you don't have to use Blazor expression inside a paragraph. You can use it in a div, in a label, in a span, in any HTML element. You can even use it in an attribute of an HTML element. For example, I'm going to say data-name equals server.name. Okay, so this is also valid. So let's give it a try. And now you see the same thing, but let's examine the HTML here. And you can see that we have a div and I have an attribute, and it has server1 inside it. So that's what I want to show you, right? You can use your Blazor expression everywhere inside HTML, including inside a elements attribute. Okay, so that's the end of this video. If you have any questions, please let me know. If not, I will see you in the next one. In this video, let's talk about explicit Blazor expression, since we have talked about implicit Blazor expression in the previous video. Let's jump back into Visual Studio here, and we have mentioned that a implicit Blazor expression starts with an @ and there cannot be any space. As soon as there's a space, then this part becomes HTML. So this limits the capability of the Blazor expression. We cannot do any string concatenation or any logic that we want to put it here. So for example, inside the definition of the server class here, we have this is online here. I want to display whether the server is online or offline in here. So for example, I want to say that is online if the server is online. Otherwise, I want to say offline if the server is offline. So how do I do that? So with the implicit Blazor expression here, it's impossible to do that kind of logic there. But with explicit Blazor expression, we can do that because the explicit Blazor expression also starts with a @ but it has a parenthesis. So therefore, within the parenthesis, you can have space. Because of that, you can do a lot of things with the explicit Blazor expression here. So in this case, we can say server.isOnline. Okay, and then if it's online, then we're going to display online. Otherwise, we're going to display offline. Okay, so this whole explicit Blazor expression generates a string, and then that string will replace this expression and display it as part of the HTML. So let's give it a try. And let's go over here and refresh the page. So we're going to see server 1 is in Toronto, that is online. So it worked. Just like the implicit Blazor expression, you can put it anywhere in the HTML. The explicit Blazor expression also can be placed in many different places. For example, you can place this inside a attribute as well. So let's add another attribute. Let's say data status equals, and we're going to say server is. We can use the expression right inside here. Let's copy this and paste it here. And then we are populating the status. Okay, let's give it a try. Let's check our HTML. Now you can see that we added a data status attribute and it says the server is online. Just bear in mind, you can use any C# expression inside the parentheses. You can concatenate strings inside it. You can use string interpolation inside it. You can use anything. Anything that is part of C# expression will be valid inside the parentheses here. I want to give another example. For example, if the server is online, I want to show everything in green. Otherwise, I want to show everything in red. So for that, I can modify the font color. Right? So I'm going to say color, and then we can add the implicit expression right inside here. Obviously here, I'm going to change it to green, and this one, we can change it to red. And let's restart the application again and try to see the changes. All right, so we have one that is offline and the other one is online. If I control F5, this time I get both of them offline. And if I control F5 again, this time this first one is online. So I use this way to generate the style, which is very good. You can use another way to generate the style. So let's change this. I'm gonna use the explicit result expression to generate the whole style here. So I'm going to use a string interpolation, and I'm going to say color, and here inside the bracket I'm going to use this, and I need to add another bracket here. It's green, and this is red, and this is going to work the same way as before, but you can see that the explicit result expression has a lot of power, right? You have a lot of option. As long as it's a valid C# expression, then you can use it inside the parentheses. All right, so we are having the server's page rendered correctly, and that's everything I want to cover for this video. If you have any questions, please let me know. If not, I will see you in the next one. In order to continue with our server management application, in this video, we are going to create a static server's repository so that we can work with some data. So we can do that inside the models folder, and let's create a class, and let's call it servers repository. And I've prepared some code already, so I'm gonna just copy and paste that over here. And then I'm gonna go through this quickly with you. So we have some data seated here. We have 15 servers, and then we have a add server method, a get servers function, get servers by city function, get server by ID, update server, and delete server, and also search servers. So let's go through that quickly. Add server, here we're just getting the maximum ID, then populate that server and add it. Right? Add this object to our servers variable here. Now, get servers is very simple, just return all of the servers. And get servers by city, we're using link to query the server's variable, and we're using equals to compare the city name, and we're getting the servers that belong to the city. In get server by ID, of course, we're doing first or default. Again, we're using link. And if it's not null, then we are going to create a new server object. Here's pretty special because if we just return this server, then anything that is changed inside this variable will also change the corresponding object inside this server's list. So that's not something I want. Therefore, I'm creating a new server object and just populating each one of the properties. Update server is quite obvious. Delete server also. And search servers, we're just using contains in the link function here. Because this is a static class with a static variable here, so as long as the application is running, you are going to have this variable accessible in your application. But every time you start the application, it's going to return back to 15 items. So this is kind of a in-memory data store. Later, we're going to work with actual database, but for now, for teaching purpose, it's better to use this static in-memory repository so that we can focus our energy on learning Blazor. That's everything I want to cover in this video. I will see you in the next one. Previously, we are able to use result syntax to render HTML with C# expressions. What about control structures like looping? In this video, we're going to learn how to use looping to output list inside our result component. So let's go into Visual Studio and let's go to our servers page component. currently we placed 2 server components inside it. So let's remove it, right? Because we want to dynamically generate this list. But for now, we're not going to use our server component. For now, we're going to use Razor syntax to loop through a list inside our static repository. First of all, in order to loop through a list of servers, we need to have a variable to store that list of servers. So we can declare a variable here. We're going to say private, and then we can have a list of servers. So I'm going to just say servers. And we can just initialize that with our static repository here. So I'm going to say servers repository, and we can just get servers by city. We are going to get servers from the city of Toronto. Okay, so now we initialize this. We need to use Razor syntax to loop through this and generate a list. For a list, we can have an ordered list. And then we just need to have several LIs. So how do we generate the several LIs? We can use for each. And to use for each, as in C#, we can write for each. But when you write it this way, it's considered as HTML. Then how do we fix that? As you guessed, we use the @ sign. Once we use the @ sign, this is considered as C#. Right? And then you just write C#. So I'm going to say var server in servers. And then I have brackets. Remember, in Razor syntax, when you use control structures, you have to use bracket. You cannot omit them. Although in C# you can, but in Razor syntax, you cannot. So always remember to write your curly braces for control structures. And then you just place your LI inside it, right? Whatever the HTML elements that you want to repeat, then just put them inside the for each loop. Of course, you can use for loop, you can use while loop, you can use any loop that is valid in C# can be placed inside this HTML section here, as long as you start it with the @ sign. So then here inside this list, we want to see the server's name, maybe the server city, and the server status. And how do we do that? We can use the things that we learned, implicit Razor expressions and explicit expressions. Right? So for example, the name here, we can say server.name and then followed by HTML. So English word in, and then followed by city name, followed by the word is, and then explicit Razor expression here. We say server dot is online. If it's online, then we're going to say online. Otherwise, we're going to say offline here. So this is all good. Again, I want to output in different colors. If it's online, I want to show green. Otherwise, I want to show red. But this time, I don't want to modify the color of this whole line. I just want to modify the color of this online and offline English word here. So for that, maybe we add a span here and then put this inside the span. And then we can modify the style attribute here. And we say color, colon, and then again, explicit Razor expression here, can put us inside. And this is going to be green, and this is going to be red. Now this is too long, so maybe perhaps we can format it a little bit better like this. Just make sure that there is a space here, and that's it. So we can restart our application, and let's go over here. And we can see that our server 1, 2, 3, 4, so all the servers in Toronto is rendered and they're all online. And no matter how much you refresh them, they won't get offline because all of the servers are stored and generated in the static repository. So let's go over here. So this is run when the application starts. In order to get a different status, you will have to rerun the application. But anyhow, you know that we have 4 servers inside Toronto, and all of them are being displayed right here. So in order to see different status, we can close this application and restart the application. And now if I go to /servers, now you can see we have one of them offline and the other 3 online. So you have learned how to use C# loop to generate a list. Right? It doesn't have to be UL and LI. It can be any HTML element that you want to repeatedly render. Whenever you want to repeatedly render any HTML element, you can use a loop and then just put the HTML element inside it and then Inside that element, you can use different Blazor expressions to express yourself and generate the HTML that you want to generate. Okay, that's everything I want to cover in this video. I will see you in the next one. This video is an assignment video. We're going to output city buttons. So let's go into our current application. We have a list of servers. Currently, we're hard coding Toronto. So we're only showing servers under Toronto. Eventually, I want to have a list of buttons that represent each city on the top. So when you click on the button, then you're going to see the list of servers that belong to that particular city that you clicked on. So for now, we are not going to implement that filtering functionality, but in this assignment, I would like you to implement the list of cities because you have just learned looping with Blazor syntax. So this assignment is to practice to use loop Blazor syntax. To get the list of cities, I'm going to provide you with a static cities repository. And that is, I'm going to create it right here under the models. So right click on it, create a new class, and I'm going to call it cities repository. And I pasted the code that I prepared for you. So as you can see, it's very simple. We just have a static cities list variable here with some hard-coded strings here. So we're going to deal with bigger cities inside Canada. And we only have one function here, which is get cities. You're going to use this function to return the list of cities. And then you're going to use Blazor syntax to output the list of cities as buttons on top of this list, right? On top of this list, perhaps on line 6. All right, that's the requirement for this assignment, and please work on that yourself. And in the next video, I'm going to present my answer. I'll see you in the next one. In this video, let's work on assignment number 1. I'll put the city buttons. Let's jump into Visual Studio now, and let's come to this server's routable component here. And we want to output the city list right here. In order to do that, we need to, first of all, have a state variable, just like the servers. The reason why I call it state variable, I'm going to talk about that later when we add interactivity to it. But right now, let's just call it state variable. And this is going to be a list of strings. And it's going to come from the cities repository here. And we can call this get cities method. And with the cities state variable, I can use it to loop through the cities. So I'm going to say for each city inside the cities variable, and don't forget the curly braces. Now I can output buttons. So I want to repeatedly output buttons. I can just use button, but let's try to see how it looks like if I just use button. And the type is going to be button. And I'm going to use bootstrap class. So btn primary, for example. And then inside here, I just need to output the city name. I have to use implicit Blazor expression here. So add city, that's it. I believe if I do it this way, all of the buttons will be connected. So I'm going to add MBSP, which is a space. And when I do it this way, you can see that it doesn't like it. The reason why it doesn't like it is because it's thinking that this is like a C#, right? So you can see this error message here. It's trying to consider it as a object or expression. So therefore, in order to make it work, we can tell Blazor that this is actually text. So by using this text element here. All right, so let's run the application and see how it looks like. Okay, let's go to servers. And we have Toronto, Montreal, Ottawa, Calgary, and Halifax. So it actually looks not bad. So let me add a line break. Let me add another one to restart the application again. Now I have a better line break here. All right, so with the space in between, what happens if I make it smaller? You can see that the buttons stay together. And I think it would be better if the button would kind of collapse a little bit and stack on top of each other once you make the screen smaller. In order to implement that, we're going to use bootstrap class, the row and columns. So outside it, I want to use a div. This div will have a class of container fluid. This is not a bootstrap course, so therefore I'm not going through this in detail. But this div is a container, and I want the text to be centered. And then inside it, I want to have a row. So therefore, I have a row, and I want it to be smaller, so W50, so the width is 50%. And then inside it, I want to have each button as a column. I'm going to say column, and then I'm going to place the button inside here. So that way I don't need to use this space here, right? And I need the column inside the for each loop. So I'm going to cut this over here. Perhaps I don't need 2 line breaks now, so I already have a div. Okay, so that's what I think I need. So let's restart the application, see how it looks like. Okay, so I have bigger spaces here, but the good thing about it is that if I make it smaller, you can see the button changes position and start to stack on top of each other. I think that's what I want. Currently, when we click on the button, nothing is happening, and that's not a problem. Later, we're going to add interactivity to this, and we're going to filter the servers list. For now, this is all we need to do for this exercise, and hopefully you have done it yourself. And don't worry about the bootstrap part. It's just some style that I want to add into this course. All right, that's everything I want to cover in this video. I will see you in the next one. Before we go any further to learn about components in Blazor, let's see how Blazor handles static resources. And when I say static resources, I mean those images, JavaScript, style sheets. And in the previous videos, we have seen this diagram, and we know that for Blazor, a request is mapped to the root component, and then the router component is responsible for looking for the components and place them inside the root component. But what about the static resources? For static resources, they're mapped directly to the resource itself. Whether it's image or style sheets or JavaScript files, it's mapped directly to the file itself and then displayed inside the browser. And what's responsible for that is, let's go inside Visual Studio here and let's take a look at this program.cs file. And if you still remember, this app object helps us to configure the middleware pipeline, and each one of these functions is considered as a middleware. So what is responsible for mapping requests to Blazor is this map Blazor components function, right? This middleware. And what is responsible for mapping static resources is this use static files middleware. So this middleware will help us to map the request that looks for static resources to the static resource itself. And in Blazor, or any type of ASP.NET Core applications, there is a specific place where you need to place those static resources. Otherwise, it's not going to work. And that place is this www root folder. This is a special folder, and you place all of your static resources under it. You can create a subfolder, and you don't actually have to create the subfolders. To help us to practice working with static resources, what I want to do is, let's take a look at the current application here. I want to show a picture about each button, and those pictures will be corresponding to each cities. And I have already prepared the images for you. So I'm going to copy and paste that into our www root folder here. Okay, I have done that, and you can see that I have images folder right here. And if you open it, I have the images that corresponds to each city, and you can see that I have the images right here. So I will be attaching these images under this lesson so you can download it and practice yourself. What I need you to do is to display the corresponding picture for each city just above the button. Maybe pause the video and try to do that yourself, and then come back and see how I do it. So let's go to the servers component here. This is the page component, and we're displaying the cities right here. Inside each column, we have this button. So all we need to do is to place an image above this button. But in order to make it look pretty, I'm going to use Bootstrap. I'm going to show you how to use a Bootstrap card. Maybe this is also beneficial to you, but you don't have to use Bootstrap card if you don't like it. So I'm going to show you how to use it. So let's go to Bootstrap and let's go to the documentation here. And if you scroll down to the component part, there is a card section here. And the card section shows you a simple card like this. You can place image on the top. So let's copy this HTML into clipboard, and then let's come over here and try to use it. So let's move this button inside. So I'm going to replace this card body here. All right, just put the button inside here. And we are going to render our image right here. So here, for the source attribute, this is where you need to use razor expression. And because you need to do a little bit logic here, therefore you are going to use explicit razor expression. So the city name is right here. Think about how you're going to do it. We're going to do a @ and a pair of parentheses. So inside it, we can use string interpolation to target the images folder, because our images are inside the images folder under www root. And because it's a root folder, so you're going to start with /, this signifies the root folder, and then images. And after that, we're going to have curly braces to do the string interpolation, and we can just use city inside here. And after this string interpolation, I'm going to put the extension name, because each one of this image is a PNG image. And I think that's everything we need here. Let's restart the application and see how it looks now. So it looks pretty big, and that's probably because it sets the width. So let's delete this and see whether that fixed our problem or not. All right, that fixed our problem. This looks pretty good. And that's everything I want to cover in this video. I hope you had fun playing with images. And if you have any questions, please let me know. If not, I will see you in the next one. This is an assignment video. You know, you have learned about routable component, but you have never had a chance creating a routable component. So in this video, I would ask you to create a routable component, which is a edit server component. Right? You can call it edit server. And then you just need to use the page directive to specify the relative URL for your routable component. And then what you need to do is to set up a link between the server and that routable component, right? So for each one of these servers, you need to have an edit link. You can use Bootstrap link button to style the link. And then when the user clicks on the link, it should direct the user to your routable component. In other words, all of these will be replaced by the content of your routable component. Don't worry about that your routable component is empty. It may just have a title, but that's okay. That's what you need to practice. Okay, I will see you in the next one where I'm going to show you how I do it. In this video, let's work on the assignment number 2, create a routable component. So let's jump into Visual Studio and let's start creating the routable component. A routable component is considered as a page. That's why it's also called page component. So you can right click on the page folder and then add a razor component. Like I mentioned before, Blazor component is technically called a razor component. And because it's a routable component, I don't want to keep the suffix component here. So just delete it. And I'm going to call it edit server. And automatically it creates a title for me. I can add a space here for now. And do you remember how to make a component routable? That's by using the page directive. So I'm going to say @page followed by the URL. So URL here, I'm just going to say servers and /edit. Right. For now, I'm going to use the edit word. And later when we learn about parameters, we're going to replace this. Okay. And the second requirement for the assignment is to have a link from each one of the server to this new routable component. So let's go to servers page component here, and let's look at this list of servers here. So we have a li element. Here I can add a space here, and after that I can add this link here. So it's going to be a anchor element. So href is going to be pointing to our edit server routable component. So / and servers and edit. The class here is going to be btn and btn link. So this will look like a link. Inside the element here, we're going to spell out the word edit. And let's give it a try and see how it looks like and how it works. All right, we have a space here and we have a edit button right here. So when we click on it, it takes us to this routable component. And if we go back, click on another one, we see this. So every single one of them takes us to this edit server component. Eventually we're going to implement this. Right now it's empty, and that's fine. Let's take this chance to actually add a link right here, because every time you want to go to the server's page, we have to manually enter it. So let's try to fix this. Do you still remember where this comes from? Right, the left hand side is a sidebar, so it is located in our layout folder. And then if we go to our main layout, we can see our sidebar, but this sidebar is a component. So if we right click on it and go to definition, it will take us to the place where the component is defined. And that is actually still in the layout folder. It is nav menu component. And if you pay attention here, we have nav link. Each one of them goes to a different place. So this one goes to the home component, and this one goes to the weather component. And how does it do it? It uses the href, go to the relative paths. So what we can do is we can copy and paste. And then this one, we're going to call it servers, or let's call it manage servers. And this is going to take us to the server's path. You can do it this way, or you can add a slash here. It should all work. Okay, let's run the application again, just to verify that everything works as expected. We see this manage servers link right here, and we can still go to weathers, come back to manage servers, and go to edit, and come back over here. Okay, that's everything I want to show you in this video. I will see you in the next one. In this video, we're going to learn about root parameters and root constraints. In the previous video, we have created a routable component, which is this edit server component. We are able to navigate to it, but we don't know which server we're editing. From this server's page, we need to be able to pass a server ID to this routable component, and that's what we are going to do in this video. Now, the way to pass information from one page to the next one is by using the URL here, and that's called the root parameter. For example, if I want to edit server number 1, I can say servers/1, then it should take me to the edit server screen where I can edit server number 1. Right now, it says no web page was found at this address. That means the resource that the URL is pointing to does not actually exist. And that's why it's spitting out HTTP 404 error. Currently, in our managed servers, no matter which link you click on, it always go to this servers.edit. So that's one of the first things we want to change. Right? So this has nothing to do with root parameters yet, but let's prepare our application. Let's go to our servers.razor page component here. And currently, we're using this URL. So in order to pass the correct URL over to the next page, we need to do /servers/the server ID. We can use implicit Razor expression here. I'm going to say server.server ID. By doing this, if we rerun our application, we have our application ready for working with root parameters. So let's go back to manage servers. And if we hover our mouse over the edit button, you can see at the bottom left corner, we have /servers and then / the correct ID. But if I click on it, it says 404, right? So that's why we need to make our edit server component routable to this place and be able to accept the root parameter, right? So this part of the URL is called the root parameter. So let's go to edit server component. Currently, it's accepting this URL pattern. We need to make it accept the root parameter. So the way to make the URL part accept the root parameter is to use the curly brace. And then you can even see that the curly brace change color. And here, you want to call it, you can call it anything, but here I want to call it ID. And then in the C# code, this part of the section that says add code and then curly braces, this is the C# code block. you work with C# in this code block. So this code block cannot have any HTML. And in here, we need to map this to our C# property. And therefore, we're going to create a C# property. Here, I'm going to use string type because I did not specify what type this is. So therefore, I can only use string type because string type can accept anything, right? So here, I can call it ID this way, so with lowercase I, or I can call it ID this way with capitalized I. As long as they match letter by letter, then they match. So that means this property should be able to accept this parameter. So here it's just complaining that it's a non-nullable, so we can add a question mark to recognize that this ID sometimes can be null. Okay, so by doing this is not enough. We need to also use a C# property here to decorate this property and saying this is a root parameter. So there are two things you need to pay attention to. First one is that the parameter name should match case insensitive. And then the second thing is you need to use the parameter attribute to decorate your property. We had everything ready. So now we just need to display the ID here just to see whether we actually can accept the parameter or not. Okay, let's give it a try by rerun the application. And let's go over here. So automatically it's already showing number 3 here. Right? So let's go back to manage servers. Let's click on the first one. Now it's showing number 1 and number 1 here. That means our C# property is accepting this root parameter correctly. Okay, let's try another one, number 4. It's showing number 4. That's the concept of root parameter and how to accept the root parameter with our C# code. That's pretty good. However, if I do something like, let's say I change URL back to edit and I hit enter, I see edit. That's pretty weird because I'm expecting integer here. It should not actually accept any type of string. It should only be integer because I want to just pass in the server ID here. So that comes to our second topic here in this lecture, which is root parameter constraint or root constraint. So a constraint will limit the type of the root parameter here. Currently, it is just a string. Now we use string to accept everything, but sometimes not ideal. In this case, we don't want to map this routable component to /servers/anything. We just want to map it to /servers/integer number. So we can use a root constraint by saying colon, and then you can see there is already a list of type that you can use for limiting the root parameter. In our case, it's going to be integer. And after we change this to integer, we also need to change this type to integer in order to match these two parameters. And now we can rerun the application and see what happens. All right, so let's go to manage servers and let's go to edit. So we're still able to map to the correct URL here. However, if I do /edit, then I get a HTTP 404. That means this URL cannot be mapped to any page component. And that's correct behavior. Right? That's what we want. Before I finish this video, I want to show you this Microsoft documentation, which is talking about the root constraint, and it gives the list of types that you can use for root constraint. It's not any type. It's just these types because you don't want to pass in very fancy data through the URL anyways. Another concept I did not cover is optional parameters. So for example, here is a root parameter, and if you want to make it optional, you can use a question mark here. When you use a question mark here, you don't have to specify this. If you only specify this in the browser, it's going to map to this component. But if you do specify this, it's also going to map to this component. It just means that one has text, the other one does not have text. Okay, that's everything I want to cover in this video. If you have any questions, please let me know. If not, I will see you in the next one. In this video, we're going to learn to use OnParametersSet lifecycle event to receive parameter values. So in the previous video, we are only displaying the parameter value on the component, but that is too simple. We need to use the parameter value, for example, to load the information about the server. Because we are editing the server, we're passing in the ID. We need to use the parameter value of the ID to load the information about the server and then display the server information on the screen for the user to edit. So then how do we use the parameter value? When the parameter is passed in through the URL to the component, and after the component is created, there is one lifecycle event that is triggered when the component receives the parameter value. And that lifecycle event, if we use override and then space, then you can see these are all of the lifecycle events we can override. The lifecycle events that I'm talking about is either the OnParametersSet or OnParametersSet async. If you're going to make asynchronous calls inside the event handler, then use the async version. Otherwise, you can use the synchronous version. Okay, we're going to talk more about lifecycle events later in the course, but for now, let's override this. So OnParametersSet is triggered when the component receives the parameter value from the URL. You don't have to call this base class method. This is not necessary. So let's delete this. Here, it is guaranteed that we're going to receive a parameter value. So this is the place where we can use the parameter value to do the things that we want to do. In this particular case, we're going to load information of the server that is referred to by the ID. So then here we can say server repository dot get server by ID. And then here we can say this dot ID. So this will return us the server object here. And for that, we can create a private member here and call it server. And afterwards, we can assign this value to it and finish that with a semicolon here. Like I said, inside the OnParametersSet, we receive the ID, then we use the ID to retrieve the information about the server. Now we know we have a server object here. So here, instead of just displaying the ID, we can delete that, and then we can write implicit Blazor syntax here. So @server.name, for example. Let's actually use a paragraph element and put this inside, okay? And then maybe another paragraph. And this is regarding the city. And perhaps we're going to show the status as well. So server.isOnline. Now, as you can see that we have this green squiggly line because it's possible that the server is null. In order to make sure that we don't encounter null reference issues, we can use a if statement here. So here, just like writing implicit Blazor expressions, we can say @if. So this is C#, and then we can have our condition. So the condition is server is not null. And don't forget brackets here. The curly braces are very important. So you cannot omit that in Blazor syntax here. So put everything inside here. So therefore, we're going to render this only when the server is not null. Now you can see that the green squiggly line is gone. And let's run our application. Let's go to our Manage Services screen here. Let's edit maybe the second server. Click on Edit. Now we come to here and we can see server name, city, and online status, which is false. So that means we're able to pull the server information based on the ID. And that means our OnParametersSet is triggered after the component receives the parameter value. Like I mentioned before, you can also use the OnParametersSet async version, and you can use this when you need to call asynchronous method. So for example, this one currently it's a synchronous method. So if we have an asynchronous method, then we need to override this asynchronous OnParametersSet instead of this one. So let's delete the second version because we are only having a synchronous method. While we are on the page, let's also create a close button here so that we can navigate back to the Manage Servers screen. So let's add a line break here. We can use just an anchor element, and so that we can navigate back to the managed servers component there. So our managed servers component, if we take a look at here, it is the servers.razor and the relative URL is just /servers. So here we can say /servers, and then we can just use bootstrap class to pretend that this is, instead of an anchor, this is a button. So we can use primary, and text here is just close. All right, so let's run our application again, just to make sure that we have our close button properly placed. All right, we see our close button here. If I click on it and come back to the managed service component here, and then let's try maybe server number 3, and we see server number 3, and all of the information is correct. Close this, maybe try server number 1. So we tested, everything is working, and this is what I want to cover in this video. If you have any questions, please let me know. If not, I will see you in the next one. In this video, let's learn to use form and input components to display and collect data. So in order to submit data back to the server, whether we're dealing with traditional web applications or Blazor applications, we need to use some sort of forms. Traditionally, these forms and form fields are implemented with traditional HTML form fields like this, with form elements and input elements and a submit button. Here, because Blazor is component-based web application framework, therefore, instead of just using plain HTML elements, Microsoft has some built-in components for us to use. Instead of using plain HTML form, here in Blazor, we can use EditForm, right? So EditForm is a built-in component which has a lot of functionalities taken care of for you. And instead of using all kinds of input HTML fields, we have input text, input number, input checkbox, and a whole bunch of other input components that are built in for us to use inside the EditForm component. So in this video, we're going to learn how to use these components together in order to create a form to display data and collect data. And then in future videos, we're going to learn about submitting the data back to the server. So let's jump into Visual Studio and get started. We're in our Visual Studio and we're looking at this edit server page component or routable component. We are going to place our edit form component right here. So we can remove this and we can start using our edit form component. Okay, so this is a built-in component. You can see IntelliSense already telling us it's coming from Microsoft.ASP.NET Core component.forms. We're going to use this edit form component to represent the HTML form. Eventually, it's going to generate a plain HTML element, but by using this, it's going to save us a lot of energy for a lot of different things like data validations and all sorts of other things. So let's start using this edit form component. So we're going to close that. And for the edit form component, so what are we editing? We're editing data. So here we're going to specify the data context for the edit form. And what are we going to do? We're going to use the model attribute here to specify the model object for the form in order to say, hey, this form is going to work with this data. Right? So here we're going to specify the server. I think we deleted something that could be necessary. So let's copy this and revert this back to what we had before. You see this if statement? We're going to actually keep the if statement here so that we know that when it comes to the edit form, the server is not null. And then inside the edit form, we're going to have special input fields. Like I mentioned here, we're going to use special input components to replace the regular input element. So here, for example, we're dealing with the name field, and we can use input text because the name is a text. And for now, we're going to display the data from the server object. And the way to do that is to use this server attribute here. So @bind value. So remember, this is a capital V. If you use a lowercase v, it's not going to work. @bind capital V value. And this is going to bind to our server.name. And we're gonna have next field, which is city. So we're gonna say .city. We're gonna bind the city property to the input text. And again, over here, we're gonna use input checkbox, right? So this is going to bind to the server.isOnline, right? Because the isOnline is a Boolean, and the checkbox can be used to work with a Boolean property here. If we have all of this, and if we run our application now, let's go to manage servers, click on edit, and now we're having input box, and a checkbox here. So we can see that we have the data properly populated. Click on the close button, check the number 2, server 2 Toronto, and it's checked. Number 3 is offline, so it's not checked. So it looks like everything is working. So now we're gonna use Bootstrap classes in order to represent the forms correctly. So let's go to Bootstrap and go over here, click on document, and let's scroll down to forms over here and form controls. Okay, so we have different ways to formulate it. So you can read through this, but I have prepared my code, so I'm gonna copy and paste that over. All right, here is my prepared form views layout with Bootstrap. And we have 1 row and 2 columns with different size. And here's the label. So for this one, we're gonna use name, and we're gonna move this input text over here. Okay, and we're gonna duplicate this for the second field, which is city. And here it's going to be city. So let's remove this. And finally, let's also duplicate this. Here we can say online, and we're going to change this one first to input checkbox. And this one is going to be is online, and we can remove this down here. Now we need some CSS classes for the input component. Class and form control, and we're going to copy this and paste it over here. And for this input checkbox, we're going to use form check dash input here, and let's do a hot reload and see how it looks like. All right, let's go to manage servers, click on the first one, and we have everything populated correctly. We have our CSS styles applied properly. And let's check the fourth one. We have online unchecked. So everything is working. This is all I want to cover in this video. In this video, you have learned to use the EditForm component to represent a form. And one of the most important part is to use the model attribute to represent the data context, right? The data context for the form. Inside it, we use different type of input components here. We have input text, we have input checkbox. Let's go over here, let's try to do this, and you can see we have all kinds of different input components here. We have dates, file, number if we need a field for number, radio button if we need a radio button, a text area, and select. So this is like a drop-down list. You have different options depending on your need. You can use different things here. We are using input text and input checkbox just for example, and in your own project, you can use those fields. All right, that's everything I want to cover in this video. And if you have any questions, please let me know. If not, I will see you in the next one. In this video, we're going to learn about form submission in Blazor SSR. In the previous video, we learned to use EditForm and special input component to collect user data. In this video, we're going to learn how to submit data. Specifically, we're learning about form submission in Blazor SSR because once we add interactivities, the process is going to be different. Blazor SSR is very similar to traditional web applications where form submission is just through regular form submission. Let's take a look at the diagram here that represents a form submission in traditional web applications. So we have a browser and we have a form in the browser, and then we have the server. So this box is just representing the server. And when the user clicks on the submit button, the form fields and its values is going to be submitted back to the server. So the URL, the form values are going to be packed together as HTTP requests and sent to the server. When the server receives the HTTP request, it's going to process that request. And there are two parts that are important for processing the request. One is the function itself, which handles the form submission event. And the other is the parameters or the variables that receive the form field values. Once we have these two things, the developer will be able to code the logic inside the function, handle the values, and do whatever the developer needs to do. Here in Blazor SSR, we have a similar process. Right? We click on the submit button, everything is packaged together as a HTTP request, goes back to the server. Now, we also need to have these two things. So let's go into our Visual Studio and see how Blazor SSR implements those two important factors in form submission. First thing first, Blazor SSR requires every edit form to have a form name in order to distinguish one form from the other form, one event handler from the other event handler. So therefore, we're going to use a form name parameter here, right? So this is a component and this is a component parameter. We need to use the form name parameter here to specify the name of the form. We can give it any name. I'm going to call it form server because we are managing servers, and here we're editing the server. So that's first thing. Secondly, we need to specify the event handler, right, which corresponds to the function that we talk about, because we need to have a function to be able to handle the form submission event. And for that, in our edit form, we have a onSubmit event handler here, and we can just specify something like submit. You can give it any name as a function name, right? So here I just put submit, and then scroll down to the code block here, and then add a function. So this is going to be called submit. And once I have this as a function, scroll up, you can see that the red squiggly line is gone. That means the syntax is accepted. Now we have the function. Then we need to take care of the second part, which is receiving the values, right? So the values of the form fields need to be mapped to variables or parameters back at the server. Here, we already have a model attribute to supply data or bind data from the server, right? Because we have a variable defined in this server, and this variable is bound to the edit form in order to display the information inside the form. Now, it's a question of receiving the data from the form when the form is submitted back to the server. So how do we do that? In Blazor SSR, it's very simple. First thing first, we're going to change this to a property. So that's a requirement. And secondly, we need to provide a attribute here, right? It's a C# attribute, and it's called supply parameter from form. With this attribute, when the form is submitted back to the server, along with the URL in the HTTP request, the Blazor framework is able to find the component, because this specifies the corresponding URL. So it finds the component, and then because of the supply parameter from form attribute, it knows that the data in the form needs to be bound to this property, then it will be able to do that. Now, what if we have multiple forms, right? If we have multiple forms, each form needs to have a form name. And then inside the supply parameter from form here, we can actually specify form name here. You can see we have form name. So we can specify the form name, and this form name will need to correspond to the form name that we provided up here, right? So if we have multiple forms, then each form will have a different name, and then the form name inside this attribute will correspond to different names. In this case, we only have one form, so we don't actually have to specify this. So let's delete it. Now we have already handled the two aspects, right? The two factors of this form submission. We have a function that handles the form submission event, which is this submit event handler here. And we have a property that handles the data mapping, which binds the form fields values back to our server property here. So we already handled those two aspects correctly. With that, we need to just add a submit button because we coded our form here. We did not specify our submit button. So let's do that. Let's add a line break inside the form. And then we can code a button here. So we're going to use bootstrap button, and it is going to be a primary button. And the type is very important, it has to be a submit button. It cannot be a regular button. And here, because we are editing servers, we can say update. And we can also move this inside here, and we can add a space in between, and we can remove this line break here. All right, let's give it a try. Let's set up breakpoint here and click on the debug button here. And let's go to manage servers, maybe go to number 3 here, and let's change online status to online and click on update. Our breakpoint is hit. So that means the event handler is actually handling the submission event. So now the question is, did our server object actually receive the form field values? So let's take a look. So quick watch is online is false. So we did not actually receive the form field value here. Actually, that's not true. What is actually happening here is the OnParametersSet is triggered again. So therefore, the server is overridden by the data from the static repository. In order to avoid having this issue, we have to make sure that we do not populate the server again if the server object already has some value. So in order to do that, we can use this double question mark. What this means is that we're only going to use the static repository to retrieve the server data if the server is null. If the server is not null, the right-hand side operation will be skipped. So let's try to do that again. Let's run the debug, go to manage servers. Let's try to edit server 1 and click on online and click on submit. Now the breakpoint is triggered. Let's watch what we have in the server variable here. And this time you can see is online becomes true. That means we are actually receiving the form fields. So those two important aspects of form submission, we have done that, right? We have our function that is triggered, and we have our server property that contains values from the form, right? So this is triggered, and our server variable here actually contains the value comes from the form. So let's continue this, and let's close and come back to maybe server number 4. Let's say I'm going to change this to 46 and change this to Toronto 1 and online. Click on update. Now let's examine the server variable here. We have server 46, Toronto 1 is online is true. So clearly we have received the value from the form submission. We just need to code our logic inside the submission now. There is just one problem here. Let's watch this again. Right? Quick watch. You can see the server ID is 0. Okay? So whatever logic that you're going to put under the submit event handler here is not going to work because we don't know which server we are going to update because server ID is 0. So therefore, in the form, we need to add something. So let's stop this, and we need to add a hidden field here in order to submit the server ID back to the server when the submit button is clicked on. So let's add it at the top or at the bottom. It doesn't really matter. I'm going to say input number because ID is a number. And we're going to bind this to, again, to server dot, but this time to server ID. And this is going to be a hidden field. So I'm going to put hidden here, and that's it. Right, so with this change, let's run debug again. Now go to manage servers, maybe add edit number 4. So again, I'm going to change to 46. This is to Toronto 1. Click on this and click on update. Now let's examine the server variable here, and we see that everything's changed. We also received server ID, which is number 4. Everything looks correct. Now we just need to code the logic inside the submit event handler here in order to update the server. And that is very simple. First of all, we're going to check whether the server is null or not. If it's not null, we're going to perform the update. And we're going to use the server's repository. And I'm going to say update server. I'm going to provide the server ID, which is server.server ID. And then we're going to provide the server object here. And that is it. So let's run our application again. Go to manage servers. This time let's add it number 2. And let's change number 2 to offline. Maybe we're going to change this to server-number 2 and click on update. Looks like nothing is happening, but because we didn't add any navigation or any stuff. But if we click on the close button and coming back to the manage server screen here, you can see that the server name is already updated and the status is changed to offline. Right, so if click on edit again, change this to number 2, right, and change this back to online, click on update, click on close. Coming over here, you can see the name is changed, status changed back to online. In this video, we covered how to do form submission. And remember, there are 2 different aspects of form submission, which is the function that handles the submission event and the model binding part, which binds the form fields to the server-side variables. In Blazor SSR, those 2 aspects are handled by a submission handler, which can be the onSubmit handler, and there are different onSubmit handlers we're going to talk about later. So you can see that we have onInvalidSubmit, onValidSubmit. In this case, we're just using onSubmit, which is fine. So that takes care of the first aspect. And then the second aspect is to receive the data, or traditionally it's called model binding. And to do that, we use the supply parameter from form attribute on top of the variable. And remember that this is the same variable that is used to bound the data to the form, which is here, right? And then we just need to specify this to receive the data from the form, right? So this is like a 2-way data binding from the attribute to the form, and then come back with the help of this attribute. And then inside the event handler, we can implement the logic that we need to implement. And that's everything I want to cover in this video. If you have any questions, please let me know. If not, I will see you in the next one. In this video, we're going to learn about form validations. So let's go into Visual Studio directly. And from the last video, we were working on the edit form and form submissions. And we know that the form's data context, which is also called the model object, is the server object. The type of the server object is the server class here. When the form needs to be submitted, what we need to do is we need to validate each one of these properties of the server object. So therefore, what we need to do is to use data annotations on the server class. So let's go to the definition of the server class here, which we define it right here under the models folder. We have the server class here, and we just need to use data annotations. Data annotations is not part of Blazor, it's part of C#. So for example, we need to say that the name and the city is actually a required field for the server class. So for that, we can use C# attribute, and we can just say required. And right now we see a red squiggly line. That means we don't have the namespace yet. So we can do control dot to import namespace, which is from the component model dot data annotations. For city, we can also say required. Is online, because it's a Boolean value, it always has a value. A default value is false, so we do not need to specify any annotations. Let's take a look at the documentation from Microsoft to know a little bit more about data annotations. All right, this is learn.microsoft.com, and we're looking at data annotation namespace here. You can see that what we used is the required attribute, right? It specifies the data field is required. And you can see that we have so many different attributes here that we can use. For example, we can use compare attribute in order to compare 2 properties. And one of the other very commonly used is the display attribute, which can provide a different name of the attribute or different label of the attribute. we have the string length, which help us to limit the length of the string. Right? So there are different things we can use. For more information, I suggest you to come here and read the documentation. In our case, we can simply just use the required field validation on both of these fields. And once we annotate our model class here, then we come back to our edit form. And in order to make the edit form validate the model object here, right, or the data context here, we need to use a couple of components at least. One of the most important thing here is the data annotation validator. So we just need to put it here. This tells the edit form to actually try to validate the model object based on the data annotations on the model class. And then we need to specify how we want to spit out the error message. One of the easiest way is to use the validation summary component here. And all you need to do is just put it here, right? And then the summary will appear on the top. Sometimes you want to have summary appear both on the top and at the bottom. So in that case, you can copy this and paste it at the bottom, for example, right here. In our case, we don't have to do that. So let's just do this. And then another thing we need to do is, instead of using onSubmit here, we need to use onValidSubmit. So delete the original, and then we're going to use onValidSubmit. You can also handle the onInvalidSubmit to do some extra processing when the data is invalid. But when you use data annotations along with data annotations validator here, the validation automatically kicks in. So you don't have to handle the invalid submit event. So here we can just use onValidSubmit, and we're going to connect to the original submit event handler defined right here. Okay, let's give it a try by running the application. All right, let's go to manage servers and let's change the first one. Suppose that we're going to delete the name and click on update. You can see that validation automatically kicks in. The data is not actually updated. So let's prove that is true. Close this. You can see the server name is not actually updated. And come back, we can still see server 1. Right? So suppose we're going to delete both this and click on update. We have both error messages shows up on the top, and this is from the validation summary component. Another nice thing you notice here is that the border of the input component actually changed to red, and this indicates there are problems with the field. Let's update the server name. Let's actually close this and try to do it again. And this time we make sure that something is actually changed, and change this to offline. Click on update and click on close. Now we don't see the server 1 anymore because we changed the city. So we're going to make sure that we don't change the city. Let's go back to edit number 2, server number 2. So I'm not going to mess with the city now. So click on online and click on update and click on close. You can see that everything is changed correctly. So this means that our data annotation validation kicks in properly. The validation error message is showing up on the top correctly. There's just one more thing. Sometimes you get a requirement where users want to see the validation error messages right beside each field. In Blazor, that is also possible. So let's try to do that here. So here, because we have for each row, we have 2 columns, we can add another column which just contains the potential error message here. So here we can use the COL class here, which means the width is going to be automatic. And we can use another control. There is a control that's called validation message. And there is a for attribute here. We can use lambda expression to specify which field is to be validated. So here I'm going to say goes to server.name. Because we are validating the server name here, that's why this validation message points to the server name. And we're going to copy and paste this 2 times. So this one and this one doesn't need to be validated because it's a checkbox. It always has a value. So we don't need to worry about that. We just need to change this to city, and that's it. And let's rerun our application. And we come back over here, and let's say we delete this and click on update. Now you can see the error message shows both in the validation summary component as well as in the validation message component right here. Right? And if I delete this, you can see the city field is required, shows up right here to the right of the field. So just to summarize, in order to provide validation, you need to do a few things, right? First of all, you need to go to the definition of the model class here, and then you use data annotations, which is a feature of C#. Okay? Just use that to decorate each one of these properties. It doesn't have to be required, just refer to the documentation. According to your requirement, what you need to do, just use that data annotations. And secondly, come back to the edit form here. We need to use onValidSubmit in order to handle the form submission event. And then one of the most important thing is that we use the data annotations validator in order to trigger the validation. And last but not least, we need to decide whether we want to just use validation summaries or we want to display error message for each field, or both. So in this case, we're using both the validation summaries as well as validation message for each field. All right, that's everything I want to cover. If you have any questions, please let me know. If not, I will see you in the next one. In this video, we're going to learn about navigate with the Navigation Manager. And we're also going to talk a little bit about dependency injection, because in order to use the Navigation Manager, we need to inject the Navigation Manager into our component. All right, let's get started. So from our previous videos, we are able to add a server. And once we update the server, for example, we update it to -1 and then click on update, nothing is happening. There could be different behaviors when you click on the update button. One behavior is to actually take the user back to the server's component. Just like when you click on the close button, it takes you back. And of course, when you click on update, you first need to update the backend data repository, and then you take the user back. The way that we use on the close button is just a simple anchor link. However, for the update button, if we go to our code here, so this is the code block, this is the event handler here. When the user clicks on the submit button, this is the event handler that handles the submission. And here we only updated the server with the server's repository. There has to be a second step where we take the user back to the servers, the managed server screen. So to do that, we need somehow use C# to take the user from this particular component, which is the edit server page component, back to the servers page component. So we need something that is called Navigation Manager, which is a class within the Blazor framework. So we need to inject that one into it. I'm going to talk about injection a little bit later. So let's start using it. So we're going to say add inject, and then I'm going to say Navigation Manager, and we need to give it a name. So typically I just want to call it the same name. So I'm going to just copy and paste it over here. Okay, and then I'm going to scroll all the way down here, and I'm going to say Navigation Manager dot, and then we can say navigate to, and here we can specify our URL here. Just the same URL as the close button. So we can just copy this and paste it over here. We can restart our application and try to see the result. As you can see, the application started, server name changed back to server 1. So let's say server.1. Okay, click on update. Now it takes me back, and you can see the server name is updated to server.1. Right, click on edit again. You can see the dot is still here. Let's change this. Click on update, and let's change to offline. Do a Control F5. Everything still stays the same. That means we updated data correctly and we navigated back to the managed servers page here. All right, now let's talk about this injection thing. What is this inject? What does it mean? Because typically when we want to use a class in another class, right here, you can consider this as another class, right? So here, typically when we want to use any class, we need to instantiate it, right? So what that means is that instead of using inject, we should do something like this, right? So let's say Navigation Manager equals new Navigation Manager. We should do something like this. And then we can use the Navigation Manager to do navigation. Why we are not doing this here in Blazor here? We don't want to instantiate a object from a class within another class. We want to inject that into our class because we don't want to have a dependency, right? This particular component here doesn't need to know the definition of this class, and it doesn't need to manage the lifespan of this object either. So here, when you instantiate an object, then this whole component needs to take care of its lifetime management. It gives birth to it and also needs to dispose it. Otherwise, there could be a memory leak. Therefore, there is a concept and a technique to resolve this problem, which is called dependency injection. And that's where this inject keyword comes. It represents dependency injection. So what that means is that this component or this class is dependent on another one. In this case, it's NavigationManager. And instead of instantiate the object from this class directly, like what we just did with the new keyword, we are injecting an instance into this particular component so that the component doesn't need to know the definition of this class, and it doesn't need to manage the lifespan of the instantiated object. And how is that possible? Okay, let's jump into a diagram and let's talk about that. I'm not going to introduce the whole theory about it, but it should be just enough for you to understand how dependency injection works in ASP.NET Core. Let's use this rectangle to represent our component here, right? So this is our component, and we said that we don't want to instantiate a navigation manager within our component, because if the component knows the definition of the navigation manager, that means if there's any change of the definition of this class, this component needs to be rebuilt. That means these two things are tightly coupled. We don't want to do that. We want them to be loosely coupled. So that's one reason. The second thing is that we don't want to manage the lifespan of this navigation manager or any class that you want to use within your component. So to solve that problem, we said that we need to use dependency injection. That indicates that this instance comes from somewhere else. It is injected into a component. Then here's the question. So who is going to take care of those two aspects? Right? Who needs to know the definition of the navigation manager, and who needs to manage the lifespan of the navigation manager? That is our infrastructure. In other words, it's our framework. So our framework needs to have a capability to do those two aspects. In this case, it's our ASP.NET Core infrastructure, because Blazor framework is under ASP.NET Core infrastructure. So in ASP.NET Core infrastructure, we have something, let me temporarily delete that line. We have something that is called a dependency injection container, DI container. This DI container is the thing that helps us to inject any object that we requires from within our Blazor components. In this case, the navigation manager comes directly from the DI container, and it is the DI container that takes care of the injection over here. And the DI container is responsible to take care of both things. It needs to know the definition, and it needs to be able to manage the lifespan. Once it knows those two aspects, it's going to be able to instantiate on behalf of our component and then inject that into our component. So let's take a look at our code here. We register the dependencies like the navigation manager into the DI container in the program.cs. The DI container here is just this service collection here. You see this service collection? This is a collection where all of the dependencies of our Blazor framework is injected, and it's injected through this add razor component function here. So let's actually right click and go to implementation. And in here, we scroll down, we see this add singleton, add scope. This is basically putting all of the possible dependencies into the dependency injection container. In this case, it's putting it into this services collection. Therefore, it knows the definition of the class. And secondly, you see this? This is singleton, and this is scoped. These are basically lifetime management. Singleton, that means there's only one instance within the whole lifetime of the application, right? And scoped means that the instance of the class lives as long as the signal R channel. This is related to the server interactivity, right? So those are the two aspects. We're not going to go too deep into that, but let's pay attention to here. We see NavigationManager right over here. So that means on this line, we're putting the NavigationManager into our dependency injection container here. And once this is registered into the dependency injection container inside a component here, when we need an instance of this object, the container will instantiate an instance and inject that object into our component. And then we can just use it. After we use it, we don't have to clean it up because the infrastructure, in this case, our services collection within ASP.NET Core will be able to take care of all of that for us. So this is the beauty of using dependency injection. Going back to our diagram here, the services collection is our DI container, and we just register all of the dependencies that we need into the container. And then when we need it from other places, it doesn't have to be a component. You can inject dependencies into your own classes anywhere that you need. And the infrastructure, which is in this case ASP.NET Core infrastructure, is able to give you the instance of the objects that you need. So this is a quick introduction to dependency injection in ASP.NET Core. And when it comes to the usage, well, you just simply go to your component and use the add inject keyword to inject the instance of the object into your component or your class, right? You need to provide a type and you need to provide a name. You might be asking, well, here you provided the class name, so there must be a dependency already. The component already know the definition of the navigation manager, so why bother? Why can't you just use the new keyword to instantiate it? Well, this navigation manager is an abstract class. So let's go to definition. You can see this is abstract class. That means it doesn't actually contain much implementation. It's almost like a C# interface. The actual implementation of this abstract class is, let's go here again, it's actually the HTTP Navigation Manager. So this is the concrete implementation of this abstract class. So therefore, our edit server component is not dependent on the concrete implementation. It's only dependent on the abstract class. And a lot of other registration of dependency injection here use interface. So this is the standard way of registering a class into the container. You use a interface as the type and then followed by the concrete implementation. Here, you use abstract class. This is also another way to register a concrete implementation. So therefore, our component is not actually dependent on the concrete implementation. It's only dependent on the abstract class or the interface. All right, to summarize, in order to use dependency injection mechanism that is built in ASP.NET Core, first of all, we need to register the definition and the concrete implementation into the DI container, which is the dependency injection container. In this case, in ASP.NET Core, it is the services collection here. And this is an extension method that contains all of registrations right here in the method. When we have our custom class, we might need to inject that ourselves. And when we do that, we just do it in the program.cs, or we can create an extension method. So we say builder.services add, and then we can either add singleton, right? And then we provide our registration right here. So usually it's an interface, something like this. So it's either singleton or scoped, right? These are different lifespan, or transient. Transient means that every time you ask for instance, it's going to create for you. It's not going to store it inside the container. You're basically just registering a interface, which is abstract definition and the concrete implementation into the container. The container only knows the definition and the implementation. And every time you ask for it, because it knows the type, it's going to instantiate the concrete object for you and inject that into your component or your class for you. So you do the registration right here, right? And then at the place where you want to use it, you go ahead and use the keyword @inject with the abstract class name here or interface name here, depending on how you registered in the container, and then the name that you give it. And then you can use this name inside your code. So thanks to our infrastructure that managed all of this for us. That's everything I want to cover in this video. If you have any questions, please let me know. If not, I will see you in the next one. This is assignment number 3. We are going to add server because we're able to rate servers. We're able to edit server. Now we want to add a server. And in this assignment, we're focusing on practicing these 3 different aspects of Blazor. First one is adding a routable component. And the second one is using forms. Here you need to use one form. There's so many aspects of using a form where you need to pay attention to when you're working on this assignment. And last but not least, we're practicing using NavigationManager to navigate away from a routable component. Try to do that yourself based on the edit server routable component, and then come back and watch the next video where I am going to show you how I implement the add server routable component. All right, I'll see you in the next one. In this video, let's work on this assignment, add server. Let's go into Visual Studio because add server is going to be another routable component as I specified here, right? So this is a specific requirement. So you need to implement it as a routable component. Of course, in a real project, you have an option to convert our edit server component right here into a multiple purpose component that can be used to edit or add, but because this requirement is specifically asking you to create another routable component or page component. So you need to do that, right? Because to convert this into a component for multiple purposes, this component is going to be a reusable component, which is going to fall under this controls. And we're going to talk about reusable components in its own section. So here, we just want to practice adding a routable components and practicing using the forms for Blazor SSR. Therefore, we are going to add a routable component under the pages folder. Right click on it and select Razor component. And remember, for a routable component, I don't want to use the component suffix. If you like it, you can still use it, but I'm going to delete everything. And I'm going to just call it add server. And click on the add button here. Here, just make it look slightly better, add a space there, and then a line break. Because this is very similar to edit server component, so we can go to edit server component and basically copy everything under this if statement because we don't need, because this is add server, when we navigate to the page, we don't have a server object yet. So we don't need to worry about whether the server is now or not now, and just paste this over here. Well, this is going to still bind to a server, but that server is something that we are going to create in our code block here. So first of all, we're going to declare a server property like this. And because this is a add servers component, so we don't actually need to get it from anywhere. We just need to initialize it. And when we initialize it, we want to specifically set it to be offline because this is a new server. It doesn't make sense to add a new server that is directly online. So set is online to false. And then let's examine our form. So in order to be able to collect data from a form, we need to use the EditForm component in Blazor. And then we have our model object, and that's our server property here that we just declared. And we can have a form name, and this form name can be the same as what we declared here in the edit server, right? They can be the same because when the form is submitted, everything is packaged together along with the URL, right? So here, add server is going to have a different URL here. So therefore, that reminds us that the single most important thing for a routable component is the page directive. And here, we're going to say servers/add. We're going to implement this later, but look at the validations. We want all of these validations here. For this server, we don't have a server ID and we don't need to submit a server ID because this is a new server. It does not have an ID yet. Okay, so we can delete this. Now, all of these fields will stay the same. We just need to change this to maybe to save. Right? It doesn't make sense to call it update anymore. And then we can still keep our close button here. Now, when the submit button is clicked on, we need to be able to receive the data here. And for that, remember we need to use the C# attribute, and it's called supply parameter from form. So that makes all of these information bind back to this server property. And last but not least, we just need to define this submit method here that corresponds to this event handler here. And inside it, instead of updating server, now we just need to add server. So here, just to be safe, if server is not now, then we are going to use server's repository, and we can say add server, and we just put the server inside it. So after we add the server, we want to navigate this user back to the server's component here, this one. Therefore, we are going to inject the navigation manager. So inject navigation manager. And again, we're going to call it the same thing and come over here using navigation manager to navigate to the server's component. I think this is it. Maybe we add another line break. And let's give it a try. All right, let's go to manage services, and we don't have a button for us to add a server. So maybe we can take the opportunity here to add a add server button. All right, so let's go to the server's component here. This is a page component, and at the very bottom, we can use a anchor link, and this is going to go to servers/add. So this is our add server routable component, and our class is going to be btn and btn primary. So therefore, this anchor link will look like a button, and we can just call it add server. All right, so let's run the application again, and we see our add server button here. Let's click on it. Now we go to our add server component here. We know that we only have 4 servers in the city of Toronto, so maybe we can say server 4.1 and then Toronto. Let's keep it offline and click on save button, and this redirects us back to the manage server screen, and we see that server 4.1 is added and it's offline and it's ready for us to add it. So we can come here and turn it on. Click on update, comes back, server is online now. So let's try to add another one, maybe server 4.2, and again it's going to be City of Toronto, and click on online, click on save. Now server 4.2 is online already. I hope you learned a lot when completing this assignment, and if you have any questions, please let me know. If not, I will see you in the next one. In this video, we're going to learn to use EditForm to delete data. Specifically, we're trying to manage servers, so we're going to use EditForm to delete a server. We need to use EditForm to delete server because we are working with Blazor SSR. So let's first of all try not to use the form to delete a server and see what happens. So this is the server's component, and this is the server list here. And then we try to add a button here. So ampersand and BSP and add a space. Then we try to add a button here, and let's give it a class. So bootstrap primary button. I'm going to call it delete. And now we'll try to handle the event, which is onClick event. And inside the event, we're going to call the delete server function, which we haven't created yet, but that's fine. We can use it and then we can add later. Here, we just need to provide server.serverID. Right? So we are deleting this particular server. So here, in order to call a function like this, we need to use explicit result expression. So add sign, parenthesis, and inside it, we're gonna use arrow function, just like this. Finish that with a semicolon, and finish everything with a curly brace here. Now we just need to implement this delete server function here. So we go down void delete server, and then it accepts a server ID. Now inside it, if the server ID is greater than 0, we're going to use the server's repository to delete the server. So just like this. If we try to run debug, right, set a breakpoint here and try to run debug, and let's go to manage servers, and we see our delete button right here, and let's try to click on the last one, and you can see whichever button I click on, there's no response. Why? Because this is considered interaction, because traditionally you will have to handle this click event with JavaScript. Here, this is Blazor SSR. Static server-side renderings. It's only server-side. There's no interactivity at all. And we are not using JavaScript, so the button wouldn't work. That's why I said that we need to use a form. Right? We need to use a form, and we put a submit button inside it so that we can use the form to submit the server ID back to the server, right? To the server code block over here. And then we can use this function to actually handle the delete event, right? For that, let's stop debugging and try to add a form inside it. Here, we are going to use an edit form. For edit form, we will have to have a model. And this model is going to be the server, which comes from this for each loop. And then second thing that is required is the form name. And because we're in a loop, if I just say form server, then it's going to create multiple edit form with the same form name. And that's not allowed. It's not going to work when you try to click the submit button. So therefore, we are going to use explicit razor expression to actually come up with different form names based on the server ID. We are going to use string interpolation inside it. So here I'm going to say server dot server ID. This way the form name is going to be unique because it's based on the server ID, and we know the ID is unique. Another thing we need to do is to handle the invalid submit event, and this is where we can just use this and copy this and paste it over here. Right, so when we submit, we just need to call the delete server function to handle the form submission event. Right? And the server ID just comes from inside as the function parameter. It doesn't actually come from the form field data. And then inside edit form, we need to have a submit button. So we can use this button to cut it and put it inside. And instead of button, the type of the button is going to be submit. And we don't need to have the event handler anymore. So let's delete this. And this is going to be called delete. This is it. Right? So when we click on this delete button, because it's submit button, it's going to submit the form back again to the server. And it's going to use this URL. So therefore, it comes back to this delete server function with the server ID provided. And it's going to actually delete the server. Okay, let's try to set a breakpoint here and run debug again. All right, let's go to manage servers, and we see this delete button here. So there is a line break over here, and that's fine. Later, we're going to convert this an order list to maybe a table. So at that time, everything will look better. Right now, we can click on this delete server number 4, click on it, and we can see that this delete server event is triggered, and hover the mouse over it, you can see the server ID is number 4. And that means we got the data and we can delete the server. So we can step into it and try to delete the server. Now if I continue and we come back, we see that server 4 is still here. Why? It's because the page is not refreshed. So let's say we go to weather and then come back to manage servers. You can see the server 4 is actually deleted. And let's try number 3. Breakpoint is also triggered. Let's continue and come back over here. Again, we got to refresh the page manually now, and we can see server 3 is also deleted. So in order to refresh the page, we can use the Navigation Manager. And again, to use Navigation Manager, we need to do dependency injection. So we inject Navigation Manager into our component. just like this. And then over here, we can try to use refresh. Right? Although last time when I tried it, there is a bug. So I think Microsoft is trying to fix this issue, but let's try to run it and see whether they have fixed it already or not. So let's go to Manage Servers and try to click on Delete. And we got the same problem that I got last time, not implemented exception. Right, so until they fix it, we cannot use refresh yet for Blazor SSR at least. So let's change this to navigate to. And what are we trying to navigate to? We're basically just going back to the same page component, right? So basically just come back over to /servers, and that's it. Let's try to run the application again. Go to Manage Servers, click on Delete number 4, and see number 4 is deleted. Click on Delete number 2. Number 2 is deleted. We only have server 1 and server 3. And if we try to refresh, let's go to Weather, come back to Manage Servers, you can see number 2 and number 4 are truly deleted. This is how we can use EditForm to delete a server. I just want to mention that another reason why we use EditForm instead of an anchor link, right? In theory, we can create an anchor link and create another page component and redirect, just like this, redirect to that page component in order to run this delete function. When we do that, it's going to work, but it's not a good practice because the EditForm, when we submit the form, clicking on the button, submit the form, it's a HTTP post and the data is not visible. Whereas if you have an anchor link like this, it's going to be stored in the browser history. So people will be able to find the URL for delete server, and they can actually manually type in that URL in order to actually delete your data. So therefore, for deleting data, it's better to use a HTTP post to perform the action for security purpose. Later, when we add interactivity, we don't actually have to use EditForm. We can just actually handle the click event like I just showed you at the beginning of this video. But here, if you just want to use Blazor SSR to complete the work, no problem. Just use EditForm to submit the information back to the server, right? And it's going to be the same page. Just define a function to handle the event, delete the data, and use NavigationManager to refresh the page, and you are good. All right, that's everything I want to cover in this video. If any questions, please let me know. If not, I will see you in the next one. In this video, let's talk about stream rendering. So far in our application, we have been using Blazor SSR. And Blazor SSR is very similar to the traditional application, as you know already, that each time we ask something from the server, it sends a request and come back with a response. One of the big problems with traditional web application, which also exists in Blazor SSR, is that if there is a heavy load in the browser, then it takes time for the response to come back. And from the user perspective, the user is just waiting. And let's take a look at how that manifests in Blazor SSR. So let's use the weather.result page, which corresponds to this particular page, right? The second one here. And if you come over here, you see that it says the stream rendering. The stream rendering attribute is used to resolve this problem. But first of all, let's delete this and see what happens if we don't have it. And let's scroll down here. It says add a half-second delay. Let's actually add a 2 seconds, maybe 3 seconds delay so that it is more obvious. Now that we made these changes, we can run the application and observe what's happening here. So let's run the application and let's go back to home and then come back to weather. So I already click on weather, but I'm waiting, and now finally I get the result. So let's try that again. Go back to home, and now I'm gonna click on weather right now. Okay, I clicked already, but I'm waiting for 2 seconds. Then I get the result. See, from the user perspective, we're just waiting for the data to come back, right? Because these data are generated from the server side, and everything needs to come back and to be rendered on the browser from the response. So now you can see that this is a problem with Blazor SSR, because everything renders statically and everything comes from the response, so therefore you will have to wait until the whole page comes back. However, in Blazor SSR, it's not that simple. In Blazor SSR, there is a JavaScript that helps us to achieve something different from traditional web application. So let's go to our root component. So app.razor. And then here you can see that we have this blazor.web.js, right? So this file is a JavaScript file which help us to deal with this type of problems. So one of the features that can help us with this problem is called stream rendering. So I'm going to change this back and add the stream rendering back again. And now if I change this to 2 seconds again and run the application, and now let's observe what's going to happen now. All right, so I'm going to home and go back to weather. And now you can see I have this loading thing going on. And then once the delay finishes, the part that is missing is kind of patched to the page. So from the user perspective, it's a better user experience. It's not like I'm waiting and waiting for the whole page, right? I already see that I moved to the weather page, right? It's just that the data needs time. So which is to the user, it's better user experience, it's more reasonable, and that is all resolved by this single attribute here. Right. Of course, something else going on here is trying to tell whether the forecast data is loaded or not. If it's loaded, then it's going to display the HTML table. Otherwise, it's just going to display the word loading. So if you are using Blazor SSR to render some more or less static page, but in that static page, you have some area that needs some long running process to load data and display, right? That part is not static, then you can use stream rendering to help you improve end user experience. So, and this is all I want to cover in this video. If you have any questions, please let me know. If not, I will see you in the next one. This is a new section of this course, and this section is all about adding server interactivity to our application. But first of all, what is interactivity? To answer that question, we need to answer another question first, which is what is not interactive. In a traditional web application, a user works with the browser, and whenever the user requests any resource from the backend server, the browser sends a HTTP request to the web server, and the web server processes that request, and then come back with a response. Then the whole page will be reloaded. So therefore, within a certain amount of time, right, maybe less than a second, maybe 2 seconds, maybe 5 seconds, even more sometimes, right, the page gets reloaded. And during that period of time, you may feel like you lost connection for a moment, right? Because the whole page gets wiped out and then comes back again. So depending on different conditions, like the connection speed, like the server's processing capability, that process may last longer or shorter. Anyway, the experience of the user is the browser is doing something and the process hangs there. So its experience is not smooth. Right? It's not like the user is dealing with a Windows application and the user doesn't see the screen refreshes. This is not interactive. But it's also a little bit confusing that the user is interacting with the browser, so there is already an interactivity between the user and the browser. When Microsoft mentions interactivity in Blazor technology, Microsoft is not actually referring to the interaction between the user and the browser. Microsoft is basically saying that this full page reload is not smooth. Therefore, it's not interactive. An interactive application should work like a Windows application. For example, this browser is a Windows application. You don't see this whole thing wiped out and come back again, right? It doesn't refresh this whole screen all the time. Whereas in traditional web application, the whole page gets refreshed. So that's not interactive. In order to solve this full page reload problem, naturally, we're thinking about instead of reloading the whole page, we just need to update the part that needs to be updated, right? So that's a partial page update, or it's also called partial page rendering. And that partial page rendering is what we call interactive. So once you achieve partial page rendering, you're going to call this application an interactive application because it looks much smoother. Right? It doesn't re-render the whole thing anymore. So traditionally, when we try to achieve partial page rendering, we use JavaScript. Instead of working like this, it's working slightly differently. So let's copy and paste this diagram. And then what is happening here is that the user interactive with something that is called DOM, Document Object Model, which is part of HTML page. The user interact with DOM. Well, the user does interact with DOM in the traditional web application anyways, but here it makes a lot of sense to point this out, that the user interact with the DOM, and then the developer has to write JavaScript in order to capture the interaction between the user and the DOM. Once that interaction is captured, the JavaScript will send request to the backend server. So typically the backend server has a web API, and the JavaScript just calls the remote web API and get the data back from the server, right? So data is back from the server. Usually it's in JSON format. And then JavaScript receives the data and maybe process data a little bit and use that data to patch the DOM. Once the DOM is patched, the page is partially re-rendered. And now the user sees the new information, which is the information that the user expects to see. As you can see, traditionally, when we want to add interactivity to a traditional web application, a developer has to write JavaScript. But in Blazor, Microsoft has different ways to achieve interactivity. Some of them involve JavaScript, but Microsoft provides the JavaScript file. Now the developer doesn't have to write JavaScript anymore. And some of the solutions of achieving interactivity is to use WebAssembly, which we're going to cover in detail in future videos. But in this video, I just want you to understand what is not interactivity and what is interactivity. Right? So to summarize, in traditional web application, the page has to reload every single time, and that is not interactive. And when you can partially render and patch the DOM, whether you use JavaScript or WebAssembly or something else, that is called interactive, right? And that is interactivity. So starting from the next video, we're going to talk about different ways to make interactivity possible in Blazor. And if you have any questions, please let me know. If not, I will see you in the next one. In this video, we're going to learn about enhanced navigation. Enhanced navigation is actually the first step toward making application interactive, and it is actually enabled by default. And that is why when we use Blazor SSR, which is supposed to be working in the same way as a traditional web application, we're not actually seeing page refresh every single time. I don't know whether you paid attention or not, but it's not actually reloading the page every single time. So let's go into Visual Studio and run the application that we have so far. Okay, if I switch between these menu items, pay attention to the browser, and as you can see, the page is not actually completely re-rendered. Especially the left-hand sidebar stays there without being re-rendered. So the only possibility of this is that the whole page is actually partially rendered. And that is actually true. When you create a Blazor web application through the Blazor web app template, enhanced navigation is enabled. And that is enabled through this JavaScript file inside the root component, which is this app component. So let's actually remove this for now and see what happens. So let's restart the application without the blazor.web.js and let's see what happens. Going back to the application, now if you pay attention to the tab, and if I switch between this, now you can see that it refreshes the whole page, and you can actually feel the refresh. And if we bring up developer tool and go to network, now if I go to weather, and you can see that here is the request that sends to the /weather page, and the type is document. The initiator is other, which means it initiated by some other page. If I go to manage server, now the whole page refreshed. And again, this is the request and the initiator is other. the type is document. Document means the whole page. If we put the blazor.web.js back and try to run this again, now if I switch between this, and if you pay attention to the top left corner, this favorite icon here, there is no refresh, right? There's no spinners going on. Everything on the page looks much smoother. Now, if I clean up this network tab here and I switch back to home, as you can see that it goes to localhost, which is home, right? But you can see the type is fetch, it's not document anymore. And the initiator is blazor.web.js. If I clean up this again and switch to weather, same thing. Type is fetch, initiator is blazor.web.js. Clean up this again, go to manage servers, I get the same thing. Now, if I go over here and click on edit server, now one is the request and it's also fetch. And initiator is also the same JS file. And another thing I want to show you is if we go to elements and we open up this and open up again, open up article. So this thing within the article is the actual page component. And if I switch between these items here, if I go over here, you see that only this portion is updated, not everything else. Now I switch to home, only this portion is updated, not everything else. This is indeed a partial page reload. Now, how does this work? Let's go back to a diagram and I'll show you how this works. Our Blazor SSR with enhanced navigation enabled, which is enabled by default. Whenever the user interact with the DOM, there's supposed to be HTTP request sent to the web server, just like in the traditional application. It's supposed to do this, but it's actually intercepted by our blazor.web.js file. And then the blazor.web.js file internally uses fetch API to contact the web server. And it sends the HTTP request to the server, the HTTP response comes back, and then the blazor.web.js file handles parse the HTTP response and get the information that it needs, and then it smartly patches the DOM, which means that the DOM is partially rendered. Now, with this model, we actually achieved interactivity, depending on the definition that we provided in the previous lesson. Partially rendered web application is supposed to be interactive web application. So therefore, Blazor SSR by default, when enhanced navigation is enabled, is actually an interactive application. Even though we didn't add server interactivity, we didn't add WebAssembly interactivity, Blazor SSR application is an interactive application because our blazor.web.js file. This file is written by Microsoft. When you work with Blazor SSR, you don't need to write any JavaScript. This application is already an interactive web application. And that's all I want to cover in this video. If you have any questions, please let me know. If not, I will see you in the next lesson. In this video, let's learn about enhanced form handling. As you can see from the previous video, with the help of enhanced navigation, even Blazor SSR can help developers to create interactive web applications. However, with enhanced navigation, the only thing the user can do is to navigate from page to page and load static pages. So what if the user wants to do something dynamic? What I mean is, for example, if we come to our application here, let's close this. Let's go to Manage Services. For example, if I click on Montreal, I want to list all of the servers that belong to Montreal. If I click on Ottawa, I want to list all of the servers that are in Ottawa. So that means the user is doing something on the page, provide some kind of information by either clicking or using keyboard. Other part of the page needs to be updated. So that's what I mean by dynamic. So with enhanced navigation, all we are doing is just navigating from page to page. Even just clicking on this edit takes us to another page. Click on this close, take us back to the previous page. So there's no updates within the same page. But with the help of enhanced form handling, even Blazor SSR can help us to make a page dynamic. Right? We don't have to make anything fancy. We don't have to have signal channel. We don't have to have WebAssembly. We can just use the EditForm component to help us to achieve dynamic content and partial page update. And in this video, let's see how that's achieved. Let's jump into Visual Studio and let's go to server component. And here what I want to do is to first of all display the server component on the servers page. So let's go to servers page and let's for now just put the server component right here in the paragraph. So server component. We have used this server component before to demonstrate reusable component. And now let's put it back and try to use it to demonstrate enhanced form handling. So for now, let's put it here and rerun the application and let's see what is being rendered. All right, let's go to manage servers page and we can see that it says server 1 is in Toronto, that is offline. So this part is from the server component. Now, what I want to do is to add a button here to toggle the status. So when I click on the button, the offline needs to change to online. And when I click on it again, the online will change back to offline. So basically the status of the server is toggled by clicking on the button. So for that, let's go to our server component and we need to add a button here. First, I want to add a space like this, and then I want to give it a button. So this button is going to have to do something for us. And in Blazor SSR, the only way you can do that is with the submit button. That means somehow we need to make this a form. Okay, so let's finish composing the button here. So btn primary and let's just call it turn on or off. So in order for the submit button to submit anything back to the server to handle, we need to provide a form, and it has to be the added form, not just a normal form. Okay, we're going to wrap all of the HTML inside the added form. Here, for added form, we need to provide a model. Otherwise, it's not going to work. And the second thing is we need a form name. Okay, so I'm going to call it server component form. Now, because I need the form, so I just need to add something to make sure the server is not now. And this doesn't seem to be useful because we're initializing this right here, but you will see why I have to do this in a moment. So I put it over here. Now, when the user click on the submit button, the information about the server will need to come back to a variable here. And for that, we have learned that we need to use the supply parameter from form attribute. And for that to make sense, this has to be changed to a property here. Now, let's actually comment out this for now. And I'm going to give it a question mark here to make this nullable. And now I can apply the attribute. All right. Once this attribute is applied, this is considered as a parameter. And therefore, our OnParametersSet is going to be triggered. So we're going to have to override this event handler here, OnParametersSet, which you learned this before. This is going to be the place where we initialize the server object. So if the server is null, we are going to initialize it, which is basically this part of the code. So let's copy this over here, and now we can remove this. Okay, so basically this line means that if server is null, then we are going to initialize with server 1 in Toronto. Now the form needs to be submitted and needs to be handled by a event handler. We learned that before, so we can say onSubmit, and who's going to handle that event? It's going to be change server status. You can call it anything. Right? This function or method is not implemented yet, but we're going to implement it right now. So here we're going to say if server is not null, then we are going to change server is online to the opposite of that. So this is going to toggle the is online status. All right. So If we do it this way, you are going to see that the server is always going to be null when it comes to here. So this is always going to be run. That's because inside the edit form, there's no input field. So therefore, nothing is going to be submitted back. So therefore, when the supply on parameter from form happens, nothing is going to be supplied. Therefore, the server object is only going to stay null. When a user clicks on the submit button, in order for the forms to be actually submitting the server information, we actually have to put all of the fields for the server inside the form, right? So I have done that. So I'm going to just copy and paste the code over here. And then I'm going to explain that a little bit. Here, you can see that we have input number, which contains server ID. We have input text, contains server name and city. We have checkbox containing server is online status. And you can see that all of these are hidden fields. Hidden fields still work. And when the user clicks on the submit button, the information of the server object will be submitted back. And when that submit back to the server, when I say submit back to the server, I don't mean the server object. I mean the backend of the server. So when it comes to the backend, the supply parameter from form will work, and the server object is going to be populated by these values. And that's what we want. After that happens, the change server status will be triggered, and the server is online status will be toggled. That's what's happening. And once the server is online status is toggled, the view is going to be updated. And as you can see, the style dominates the color change. So therefore, we are going to have the color change. All right, so let's rerun the application and see what is going to happen. All right, the application is updated. Now we can see it says server 1 is in Toronto, that is online. And if I click on turn on or off, you can see that it actually changed to offline now. And the color changed to red. And if you pay attention to this, let's close this first tab. Just pay attention to this icon here. I click on it. You can see that it's actually refreshed. The whole page gets refreshed. So what if I do it this way? Here, okay, so I make this border smaller. And then if I scroll down to this line over here, I click on it. You see, the whole page reloaded. And therefore we lost our scrolling position. But if we scroll down, you can see the status actually changed to offline. Let's try this again. Now it's offline. I click on the button, the page gets refreshed, and it's changed to online. So our logic works. The only thing is that the whole page gets refreshed. Another way to demonstrate this is that let's go to network, and then let's click on turn on or off. And you can see that the server's page is a document and triggered by other. That means the whole page gets refreshed. If we watch this part as well, let's open it up, scroll down, click on it. You see this whole thing gets refreshed, and therefore the elements collapsed. That means that we made this page dynamic. Okay? The user provide information and the backend server handle the information. The problem is now that the page is not partially rendered, it's completely re-rendered. And that's not interactive. We want the page to be interactive. And that's where enhanced form handling comes to rescue. We are using edit form to try to achieve dynamic. However, that dynamic is dynamic, but the page is not partially rendered. Enhanced form handling will make the re-render partial. And it is actually very, very simple. We just need to add an attribute here. So enhance equals true. This is also called parameter of the component. We set it to true. When we do that, let's rerun the application. And let's go back over here. We scroll down and click on turn on or off. Now you see we don't lose our position, but the page is actually updated. You change to offline. Click on it again, change to online. Click it again, change to offline. And if we watch here, right? So let's open up, go to main, go to article, and we see our form here. Click on the button. You see, the page is not reloaded and the information in it is updated, right? So page is partially reloaded. And now let's go to the network tab and let's try to click on the turn on off button here. And as you can see, every time I click on it, it goes to the server's page, and it is a fetch type. And initiator is also the blazor.web.js. So you can see that the enhanced navigation and enhanced form handling is relying on the blazor.web.js. Therefore, you can see that enhanced form handling is using the same technology, which is all relying on the blazor.web.js. Let's go back to here. The enhanced form handling is also having the same structure here, right? The user interact with the DOM. And then when the form is submitted, there's supposed to be HTTP post request goes to the server, but it's actually intercepted by blazor.web.js file. And then the JavaScript internally sends a fetch API and get information that is needed and then patches the DOM. And that's why you're seeing this initiator blazor.web.js and the type is fetch. And it's so simple. You just need to remember to use the enhance to set the enhance to true on the edit form. So that means with Blazor SSR, you already have all the tools to achieve interactivity. You can make the page interactive, you can make the page dynamic, and you don't have to do a lot of extra things, which is going to help us to partially render the page when we navigate from page to page. And with the help of enhanced form handling, we are going to be able to partially update the page when we need to make dynamic changes on the page. With these two features that is added in .NET 8, we can use Blazor SSR, static server-side rendering, to achieve almost everything we want to achieve. However, there's something even better, which is called Server Interactivity. And I'm going to cover that from the next video. That's the main thing we're going to cover in this course. What is Server Interactivity? So in the previous two videos, we have talked about enhanced navigation and enhanced form handling. And we were able to see that by using those two features, we are able to achieve interactivity. Our applications are actually interactive. But when Microsoft referred to server interactivity or server interactive, they actually mean something similar, but also different. So if we go back to enhanced navigation here, or even just go back to this diagram, we can see that the way to achieve interactivity is to use a JavaScript and work with the DOM. And then the JavaScript will work with the backend server. With enhanced navigation, we're using the blazor.web.js file to work with the server. So it's all about the JS file. The actual server interactivity is also relying on the blazor.web.js file, but this time the request and response is different. So let's copy this diagram and see how the server interactivity works here. So we have the same diagram, but here is different. Instead of using the blazor.web.js to send fetch API requests to the web server, server interactivity is using the blazor.web.js file to set up a WebSocket channel, and that is called a SignalR channel. So let's use this bar here to represent the channel. And let's change the color to slightly like silverish. So what happens is that the first time when the page is rendered, there has to be a request and response going on here. So a HTTP request goes to the server, and then HTTP response comes back, and that renders the DOM. That also makes the JavaScript file available inside the browser. And then immediately a WebSocket channel, which is the SignalR channel, is established between the browser and the server. When this SignalR channel is established on the web server here, let's remove the letters here. Inside the server here, an in-memory representation of this page. Let's use this rectangle to represent that. So a memory representation of this page is held inside the memory, right? And that is actually connected with the SignalR channel. So therefore, when the user interacts with the DOM and when the Blazor.web.js captures that interaction, messages, in this case is like actually binary messages, will be sent inside the signal channel, right? Like this. And here, when the in-memory representation of the page receives that message, it will interpret it and it will process that. And when the process is finished, binary message will come back through the channel and captured by the Blazor.web.js file. Now, this JS file will interpret the binary message and then it will patch the DOM. So the difference between this and this is not only in how this communication is done, but also the backend is completely different. Right here, this is still a request and response model. The web server doesn't hold anything in memory. Every time a response comes, it will load objects into the memory and do the processing, and then request comes back and everything will go out of memory. Right? Another request comes in, the objects will be created again, and then response goes back, the objects will be disposed again. Here, everything is held in memory. A signal channel is held consistently between the browser and the server, specifically the component or the component tree. And the communication method is using the signal channel, and what is going on between the channel are actually binary messages. So the communication is pretty fast, and the messages are made in a way that they are very efficient, very minimal, so therefore the performance is not bad. Now, to make this part more clear and see at the backend how this all works together, I have to mention another concept, which is something called render tree. So in the DOM, we have the concept of render tree. All of the HTML elements are grouped together in a tree format. We have elements, and then one element may have its sub-elements, so it looks like a tree. In the backend, when the in-memory representation of this page is held inside the memory, there is also a render tree that is held in the memory. In fact, there are two render trees. Let me use this diagram to represent the render tree. Let's say I use this component to represent this component. And this component actually has two subcomponents, or in other words, two child components. And this is a tree. So this render tree, it needs to be rendered inside the DOM eventually. But currently it's held in the memory. And this is what we call the previous render tree. And this previous tree is held in the memory. So after the user interacts with the DOM, and then the Blazor.web.js send a message to the component here, the component inside the memory processes the request, and then it will generate another copy of the tree, which is a new copy. And the new copy of the render tree represents new information. So this is called new tree. Right? In this new tree, perhaps some information in the child components are updated, or perhaps another component is loaded like this. Now, Blazor is going to compare between these two render trees, and it will see the difference. In this case, obviously, there's an additional component added to the tree. So therefore, it's going to pack this component into binary message, and it will send this information to the Blazor.web.js in the browser. And the JavaScript file here, understand that there's only this additional component is added, then it will patch the DOM with this additional component. So what this is called render tree difference. And that render tree difference is understood by the Blazor.web.js, and the JS file updates the DOM. The user sees the difference now. So that's the whole process. That's how Blazor Server Interactivity works. Okay, just to summarize, when the page is just loaded, it's based on HTTP request and response model. And then the DOM gets all of the information, including the JS file. Immediately, the signal channel is established. And then when the user interacts with the DOM, the JS file send binary messages. The component inside the memory is going to capture that message, process that message, create, add or remove information to the render tree, and then it's going to compare between the previous render tree and the new render tree. Is going to see the difference. It's going to get the div between the render tree, and then it's going to only send that div, not the whole tree, back to the browser. Now the Blazor.web.js captured that message and understand that message, then it's going to patch the DOM. So therefore, the page is partially re-rendered, and that achieves the server interactivity. That's everything I want to cover in this video. And in the next video, we're going to see how to actually enable server interactivity and how to use server interactivity to do a lot of things. In this video, we're going to learn how to enable server interactivity in order to make a component interactive. We are actually going to work on that in Visual Studio. So in order to demonstrate that, we are going to make this server component, which is this one, interactive. Well, we already made it interactive with enhanced form handling. But this time, we're going to remove the enhanced form handling. We're going to use server interactivity. So let's go ahead and do that. Let's remove EditForm along with all of these views. We don't need that anymore. And let's remove the clothing tag here. Now we can recover this, and we're going to initialize the server variable here where we define it. And then I'm going to delete this OnParametersSet, and we're going to delete this event handler as well. Now this button has to be now changed to a button, and we can just handle the click event. So here we are going to say we want to change status, and now we are going to declare this change status function inside our code block here. And inside here we can simply just say this dot server dot is online equals the opposite of it. So if this is true, then the result will be false. If this is false, the result is true. We can use something like if server is not now, then we are going to set it. All right, let's try to run this application, and you will see that the breakpoint here is not going to be hit. Right? Let's set a breakpoint here, run the application in debug mode, and now let's go to manage servers. We see the server is in Toronto, that is offline, and click on it. Absolutely nothing is happening. Go to network tab here and again click on this. You can see nothing is happening. That's because we haven't actually enabled server interactivity yet. So let's go back and stop debugging. And then let's go to Solution Explorer here. Let's go to program.cs. This is where we can enable server interactivity. First thing first, in this map razor components function here, we can connect that with add interactive server render mode. And then at the dependency injection part, we talked about dependency injection before, right? Here we can also connect that with add interactive server components. So this provides all of the dependencies for this to work. And those are the only two things you need to do here. Once these two lines are added, we can rerun the application. Right, rerun it in debug mode. Now, if I go to manage servers and click on turn on and off, and you can see it still doesn't work. So there is another thing that needs to be added. So let's go back over here and turn this off again. Now let's go to servers.razor where the server component is added to the managed services page component. Here we need to specify the render mode. So render mode equals interactive server. And that's it. That will enable server interactivity. Okay, so there are two things you need to do. One is in the program.cs. You need to add these two lines. Secondly, you need to specify the render mode. And there are different places we can specify the render mode. I'm going to talk about it a little bit later. Right now, let's just run this application and see how it works. But before we do that, remember to delete this paragraph element. It's going to actually cause some issues with the server-side rendering. Turn it on. So let's remove that because it's not necessary anyways. All right, let's run the application now. And we have a breakpoint set up here. So let's run the application now and see what's going to happen. All right, our application is running. Let's go to manage servers and we see our component here. Server is in Toronto, that is offline. Let's click on the button and you can see that the breakpoint is triggered just because we added an event handler here, right? There's no forms, there's no HTTP post request. It just works. And let's remove the breakpoint and continue. Now you can see it's turned back on and click on it. We'll make it go off, on, off, works very well. And now let's examine the network tab here. So F12, bring up the developer tool and go to network here. And let's scroll down and click on turn on. And you can see there's no request coming on, right? There's nothing going on here. That's because we are not actually watching the SignalR channel. So in order to see the SignalR channel, let's actually refresh this whole page. Right? So this first time when the page is refreshed, what is happening is exactly in the diagram that I showed you. Right? First time, there is a HTTP request and comes back with a response. That renders the page. And that also renders this blazor.web.js file. So we can see that it goes to the server's page as a document, and then the blazor.js file is downloaded to the browser. And we have SignalR channel that is established. In order to make it clearer, let's make it separate. So this is the one that we were looking at. This is the actual SignalR channel. So the other two are made for Blazor SSR, so they are not actually being used constantly. This is the SignalR channel that's established between the browser and this component inside the memory on the backend. If I make this appear on the left hand side and make this appear on the right hand side, and now if I click on the button, you can see the message is growing. See, 2 message goes to the server and 2 message come back. Each time I click on it, the messages are being sent back and forth. And you can see the length of the message, a few hundred bytes. So pretty tiny. And that's the diff between the render trees that I mentioned in the previous video. So in order to review how Blazor Server Interactivity works, I'm going to take this opportunity to go through what's happening in that diagram again. So when I click on the turn on and off button, this event is captured by the blazor.web.js file. And a message is sent to the memory representation of this component in the backend, right, on the server. That component receives that little message, a few hundred bytes, and then it executes this function. When the function is executed, the state variable here, which is online, is changed. And when that is changed, the HTML here is re-rendered. And that render tree is compared with the previous render tree, and then we'll see the difference, right? You will see that the word changed, the color changed. And that information is packaged together as a binary message sent back through the SignalR channel. Now, the JavaScript on the front end received that message and patched the DOM. So it changed the color right here, changed the word offline to online. And if I click on it, this is happening over and over and over again through the SignalR channel. In this video, we're going to learn about Interactivity Location. I'm sure you have seen this term on the Visual Studio template, but what does it actually refer to? So let's come over here, and we made this component in the previous video. In the previous video, we made this server component interactive. And what we did was that we added this line in the program.cs and this line in the program.cs to enable server interactivity. And then that's not all. Inside the servers.razor, where we use the server component, we specify this render mode and we set it to interactive server. So this is called interactivity location because there are different locations you can set the render mode. Therefore, this location is called interactivity location. Generally speaking, there are two different categories of interactivity locations. The first type of location is set on the page or set on the component. For example, for this location, where you set the render mode on a component. Either you set it right here, where you use the component, or you set it in its parent component, or you set it inside the component. It's all going to work. And you notice that all these three different locations belong to the first category, where you set the render mode either on a reusable component or on a page component. So let me demonstrate that. That's the first category. So first of all, I want to remove this just to make sure that removing the render mode actually takes away any server interactivity. Let's go over here, and then when I click on this, you see nothing is happening. So the first category of specifying the location of interactivity is at the place where you use the component. But it doesn't have to be on the component. It can be on its parent component. For example, I can specify the render mode here. And when I specify it right here in the page component, then the page component itself and all of the subcomponents, this entire component tree is using server interactivity. So now let's go over here and I click on this. You see it's working. It's working very well. So you can set it in the parent component, no matter whether it's page component or reusable component, or you can set it at the place where you use it right here. Or you can specify it inside the reusable component. So you can do something like this. And when you do it like this particular component and all of its subcomponent, right? This entire component tree starting from this particular component will be using server interactivity. So let's go over here. This is still going to work. See? So this is the first type of interactivity location. In this type of interactivity location, you specify the render mode on the component, either the component itself or inside the component or in its parent component, depending on your need. That's the first type. So the first type of location is at the page or component level. Now, the second type of location is at the global level. So if I roll back all of the code, and then let's go over to server's component here, and let's remove this render mode. So now there's no render mode specified, so this component is not going to work. But let's go to the root component where the router is. So if you still remember, all of the requests go through this router component. This is the root of everything. So if I specify the render mode right here, and if I set it to interactive server, then the entire application will have interactive server enabled. Right? Entire location is going to use server interactivity. So this is called global location. In fact, in terms of interactive location, it doesn't matter what type of interactivity you are using. You can use interactive server, you can use interactive WebAssembly, or you can use a combination of that, right? Interactive WebAssembly, which we can cover later. But in terms of location, these are the two different type of locations. Once you do it here, the component here is going to work. See, it's working. It doesn't matter where you use interactivity, and you see this is working. The server interactivity is going to work under the entire application, no matter which page component or reusable component you write code, you can use server interactivity. All right, those are the two types of locations. But what is recommended by Microsoft is to use what we used. So let's roll back everything again. So what we used is that we are specifying the render mode location on the component level. Because we know that out of all these applications, every page component, only this component here is using server interactivity. Therefore, I specify the render mode to be interactive server right on the component. And you may ask, can I just go inside here and specify it on top of this component? That way, I'm just specifying that this component is using server interactivity. That's not actually recommended by Microsoft. Because later when you learn about WebAssembly interactivity, you will know that you can actually enable WebAssembly interactivity on this very component. So if you specify your render mode inside this component, you kind of locks your component interactivity mode. Therefore, it's not recommended to specify the interactivity inside a component. It's recommended to do that outside the component where you use the component. So you specify it as an attribute. You just need to remember there are two types of interactive location. One is on the component or on the page itself. The other one is global location. Global location is achieved through the router component right here. You specify the render mode right here. The other one, you specify it at the place where you use the component. And this is a recommended approach. Okay, that's everything I want to cover in this video. I will see you in the next one.